Assalamu alaikum, everyone. Hello, can you all hear me? Can you all send me a response, please, so that I know that you all can hear me? Am I audible? Or like, am I just talking? Oh, wait, the chat is disabled. I'm getting WhatsApp text. Admin, can you please look into it? Why does it say the chat is disabled? But let me look into that. Give me a second. And now it's sorted. Now can, right? I can reply. Are you there? Okay, I'm getting text. Okay. Yes. Okay. So it's audible, right? All good then. We can start. So before I actually start the session, now I'll be telling a few things now because this is the first session. So I'll have to start with an opening, right? So until then, I want you all to send the link to your friends and whoever isn't here yet. If you can send the link so they can join, it will be awesome, right? So wait, give me a second. Give me 1 minute. Right, all good. Okay, right. So now I will start with a few things, right? So these are like very general things that I have to tell before we start the whole webinar series. So if I am like a kind of boring, or if I'm, if you already have heard this, because if you have joined last year, I would have said the same thing, but this time I'm going to say some things that are extra, right? So until then, if you feel like, no, this is the dude for science, if you had gotten it, you all have it, right? So if y'all don't have the queue, that's okay. I told you to print. Okay. So until then, okay, till I talk and tell you about the whole webinar thing, I would prefer if you can, do this, the equation, like page number, this one, right? Equations at one glance. So until I tell about the whole webinar thing and how it works, because if you are new to this, then I'll have to properly tell about how it's going to work and what you can do and how it can help you for your O levels and all of that, right? So until then, you can answer this, the equations at one glance, right? That's the whole point of this because you have studied all of this now. So you can just maybe put the equations in here, right? If you have already done this, then I told you to bring color pencils now. So go to the last page. I think, yeah, here, right? You can just color this, or if you remember, oh, I have to do this after O level. The first thing is sleeping. No, that's the first thing for anyone, right? So if you have something else to do other than sleeping after O levels, you can just write this, right? And yeah, color or do whatever. Okay, as long as you're paying attention, right? So I need your attention for this. So okay, so now about this whole webinar series. Now, if you have joined last year, you know that it might have helped you a lot because I got so many feedbacks on this. So it's actually done for your benefit more than ours, right? So it's actually done so we can help you in a way that we're actually training you so you go for the exam very confidently. So what we get in return would be maybe to touch popularity. That's it, nothing else, right? Because it's entirely non-profit, right? From the people who are working behind the scenes, everything is non-profit. Like we're not getting anything, nothing in monetary value. Okay, so what you can do in return is to be active in all possible sessions, right? In everything possible, right? Be active as much as you can, right? Now, it's like I know you have classes and other stuff. For that reason only, we're live streaming it on YouTube, right? So that, if you miss it a little also, you can soon go and join from YouTube and watch, something like that. So try to make maximum use of the opportunity that you're having, right? So this is just for you, right? Now, people who are affected by floods and all, sometimes they have no way of joining classes, right? So for that reason, this is that kind of a support that we're giving from our side, okay? And it's not very easy as you think, it's not just like some randomly we thought, okay, let's do some classes, extra sessions and all, and we all came together. No, it's not like this. It's quite hard to bring in teachers and to ask them, can you voluntarily help us for this and all of that. It's not easy enough. So, and also these teachers are very qualified, okay, very qualified experience. Now, I would recommend, now, if I can personally recommend, I would tell you that the Sinhala teacher is my own teacher, right? So she's awesome, right? I would always recommend, if you're doing Sinhala, please join the session because you're going to learn a lot, right? Sinhala is one. Another one is Islam. The two teachers are so good, especially the boys teacher. She taught me Islam during my O levels, right? And Arabic language, she's also qualified. She's my friend's teacher. So like that, we were able to get the best teachers for her, right? So please don't take this for granted and think that, oh, they just bring it for free. No, so if I want, I will join. No, right? Because there's no time for you to watch recordings either. It's gonna pile up, and then you have to watch after O levels only. So it's gonna be hard now. So try to make maximum use, whether you have studied the syllabus before or not, right? Sometimes you would have studied the syllabus already, like at least once you would have covered the syllabus, that's fine. But some of you are doing O levels in December, right? So how many of you are doing O levels in December? Can you send me a text just so I can get an idea if you are doing in December in my session? How many of y'all are doing in December? I don't want to be yapping if you're not replying. So I just want to see. You can hear me, right? Or am I just talking to the wall in front of me? Okay, somebody's raised their hand. Amna raised her hand. Who else? In December? Can you at least raise the hands? No. Okay. Rimza, and there's a no-name person. Okay. Right. So some of you are new there. That means last year you all didn't join, right? So most of you who joined last year are doing O levels next month. So, anyways, it's gonna help you all also a lot, right? So now electromagnetism and all those lessons you all haven't. I don't think you'll have studied in school. If you all have, then it's awesome. If you all haven't, it's okay, right? Today will be the first time you're learning them, right? So at least you can catch from this, so try to be kind with the teachers because they are among their busy schedule. They're coming forward and trying to give you some support, right? Just a month before your exam. Now, even after this webinar finishes, you still have 1 month left for your O level, like almost 1 month. You can't really say 1 month, almost 1 month. So in that, after that, you can do your self studies and try to brush up even more, right? So this is like kind of a support for you. Okay. And when the webinar finishes, like on the last day, on 30th, after the Sinhala session, I have scheduled like a 1 hour, right? A guidance session that's done by me again. And there I'll be teaching you how to answer the paper and what to do, what not to do in the exam because it's practically your first exam. So I'll be practicing or not practicing, kind of guiding y'all on how you can answer the paper. It's more of like a guidance session than a motivation session, but I will do both, right? So I'll try my best to do both, and I'll also give you a plan for science maybe on that day, so you can follow it until your exam, right? And until your exam, these tutors will be helping you, right? So make use, right? Don't think that it's for free, I'll just let it go, and no, don't do that, right? If if Allah or your God is giving you a certain chance or opportunity, try to make maximum use of it, right? Now, this is an opportunity that you have got. So try to, if you have doubts, you can contact the tutor, right? Contact directly and ask them, what is the answer to this or how can I do this? They'll always help you. Okay. That's what I wanted to say. But always be kind. Okay. I accept constructive criticism. Now, if you tell that he could have done like this time, then I will follow that and do it next time. Right. But I don't like it if you insult the teacher or kind of, if it's not nice, no, because someone is coming to help you and you're just saying that, oh, you're finding faults in them. It's not nice, right? So practically, I would appreciate it if you all can give an honest, good, positive feedback. And if there are some things that can be corrected from our side, then I would appreciate that also, right? And that's another thing. Last time I also told this one thing that I want to repeat this time, which is about targets, right? Now, most of y'all, right? So most of y'all have this habit of following targets. Whatever targets y'all find a month before or a day before the exam, you all will take the target. look at it, follow it, and it won't come. That's the best part, right? It will not come. Something other than a target only will come. That's the hard truth. Okay. So most of us, including myself, for Sinhala O level, I followed target, and it didn't come. I mean, not only me, even my friends followed it, so I was on the safe side. Sorry if my friends are here, but yeah. So all I can say is don't follow targets, right? Don't ever trust targets. Okay. So yes, you're welcome for making this free. Yes, you're welcome. Yeah. So and anyways, make maximum use. That's all I can say. Yeah, so don't follow targets. Back to my point, don't ever follow targets. If you come across targets, just look at the topics and just try to study that more. But that doesn't mean you only study that. Okay, it's okay to look at the topics and be like, oh, this topic, you look at it even more, that's fine. But don't only look at that. That's what I mean. Right? Target doesn't mean you only look at that because that won't come. That's the hard truth, right? I did the same thing for A levels also, and it didn't come. Okay, so don't ever follow targets. That's another thing. I'll stress on that on the guidance session day, right? And also, now I told you about the self-studying thing. No, now throughout when the session is going, it's best if you make a plan for yourself. Okay, take this as your last chance. Okay, make your own plan. Okay, now I'm saying now today you have physics. No, so today you make sure that you study all the physics topics because physics topics is not. I mean, there is quite a few, but it's not the entire science syllabus, right? Just a selected physics topic, at least until like before you sleep, because most of y'all you stay awake until 1 o'clock, 2 o'clock, so you won't do anything, right? So until that time, at least try to study the physics topic. Whatever I taught you today, make sure you study that. And tomorrow, before the Tamil session, make sure that you cover everything possible in physics. And then get ready for Tamil. If you're not doing Tamil, then make sure tomorrow also you do physics. Somehow may take our calendar and make your own study plan because that is going to help you a lot, right? So cover like try to answer the cute questions of whatever our teachers have provided to you, and try to make it effective as possible. Another thing is another advantage. Okay, if you join our sessions, right? Because it's free also, you can just join it and be engaged. Engaged means talk to teacher and all of that. The teachers will tell me who the active students were. So those active students will be recognized in our social media pages, and y'all can get some popularity even by doing this, right? So you're going to get popularity, you're going to get free education. Oh my god, that's like awesome, right? Okay, anyways, I mean we never had this, so at least y'all are having this. So make some use of, okay? And some people might say, another thing is, some people might say, O level result, of course, it's not that important, it's just like people will forget it anyways. No, it is very important because it's practically your first public exam. No? If you forget scholarship, okay, it's like some of us, we didn't do scholarship, including myself, I didn't do scholarship, right? So, O level is like your first public exam. So make sure that you do your best, right? So it's like the start, it's like the foundation, right? So if you don't do the best, then throughout your life you'll have some regrets. You'll be like, if I had done O levels properly, I could have chosen the stream for A levels I like, something like that. So try to do your best in O levels, no matter who says what. Okay, I know when you do degree and all, O level results mean nothing, right? But that's your first exam, so try to put in your best effort and do the best that you can. Okay, and eliminate all possible distractions now. Now is not the time to have Instagram, Facebook, this TikTok. No, now is not the time to do all of that. So if you have social media now, I would say it's best to uninstall everything now for now because you only have 1 month. No, what's the least that you could lose, right? So now you only have like 1 month left. So at least in this 1 month, delete all your distractions. Of course, keep WhatsApp, okay, because you need to talk to your teachers and all, so keep WhatsApp and all the study apps. But the rest of it, now it's time to let go, right? So now you have to sit and study. That's the only thing that you have to do. Okay. Oh, and I forgot to welcome you all, right? Okay, welcome to Elevate 25. Okay, that was random, but this is something that you can say, oh, it's a welcome thing. Okay, anyways, I'm losing brain cells because all the information is stored in my head. But anyways, I hope you can get what I'm trying to say, and you can always text me on anything. Okay, not just science. Anything you can talk to me related to the webinar. If you feel like this could be done that way or something, you can talk to me. Okay. And even another thing that I want to say is, inshallah, we're hoping to have, once this webinar series is completely done, I was thinking, it's just a thought, right? For the December people, now some people raise the hand, right? For the December ones, I'm thinking of having like maybe from next month, because this month we're having the webinar, no free webinar. So next month onwards, I'm hoping to start like an express division, not for all the subjects. For the tutors who are in our academy, I was thinking to start something like this. So it's like a course, not a course, I think it's a class from maybe May to until September to cover the whole syllabus kind of a thing. So if you want to cover it again, this is for the December people. Okay, so I'm not saying the February people don't join this because you have to do A levels then. So don't join for O level class again. Okay, I hope you don't. Yeah, so please note that I will properly tell the plan and all later on. Okay, so and ask your friends to join. Okay, so there are 50 students, so ask the others to join on Zoom itself, because if it reaches 100, then they'll have to join YouTube. Okay, and always interact with the tutors. Okay, now with me also you can talk to me. I'm not going to judge you and be like, oh, she's talking to me. No, like you can talk to me, always interact, because I would love it. Then I will notice your name, and that way, it will be nice. Okay, I don't think I have allowed the unmute option, so always, because if not, it will be like a fish market. No, it will be like a malukade. So I don't want to allow you all to unmute it. So send me the text on chat. Okay, so stay focused first of all, and then if you have doubts or anything, please send it to me in chats. And that's it for now, I guess, right? If I have anything else to talk about the webinar, I will let you all know. Okay. But one thing for sure is this webinar series is better than last year. If you had joined last year, it was the first time we did it last year. So this time it's much better. Next time, I'm hoping to make it even more better. Next time, the sense probably in September or October. Let's see how it goes, inshallah. Okay. So that's it for now. We will start with the lesson. Okay. Now there's another 4 minutes more to 7:30. My initial plan was to start at 7:30. So now it's 7:26. Talk about punctuality, huh? Okay, anyways, can you have you all sent the link to your friends? If you all have, ask them to join, because we need more students to join. I hope they're not in YouTube at the moment, because in YouTube, I can't see your chats, okay? So I only can see your chats in Zoom. If you have any questions, you can ask me about the webinar or anything. I can clarify until 7:30. So we have 4 minutes left. And I think I told everything that was needed to be told, right? So if any other questions, you can ask me. We can unmute. Admin, what are you doing? Can you can you mute them? I don't want you all to unmute and then no. Thank you. My letters are pretty. Actually, it's baby letters, but please, just for 3 hours, try to this thing. Okay, try to manage with it. And I think I'll start now itself. Okay, I'll start now itself. Oh, okay. So you're doing O level second shy. Will this session? Okay. Yeah, this session will be useful whether you're doing second shy, first shy, whatever. If you're doing O levels, then this session will be useful. Okay, so don't worry about it. At last, it will become Maluka Day. That's my same worry. I don't want it to be like that. I don't know. Zoom is weird now, but some of my friends are offline. Call them, and ask them to come. Miss, will we cover electronics? I don't know. Electronics, I love the lesson. Okay, it's an awesome, awesome lesson, right? Electronics is like one of my favorite lessons, but unfortunately during this 3 hours I can't do this. Okay, I will only be able to cover electromagnetism and electromagnetism and hydrostatic pressure. So these are the two things I'll be covering mainly, but the other stuff like electronics and all, there are like small minor points like NPN transistor and like a few random points I'll be able to do in the session, right? So that way you won't forget those points. No, so like electronics, forces. Now forces were easy for y'all, right? Now I will start with my lesson thing. Okay, and I feel like I don't know why Zoom is a bit weird. It's like your messages are here and there. Give me a second, I'll sort it out. But is it possible to order the queues? We kept it open for like weeks now, and we closed it. So I don't think we can. I'll ask them and see, because I'm not the one who's putting your orders and stuff. So we have a separate partner who's doing that. I'll ask them and see. Okay, I'll let you know. Send me a WhatsApp text because I might forget. I've sent the link to them. They will join us. Okay. Can you give us study plan? Yes, I'll give a study plan for science on 30th. Okay, because study plan is not easy. I can't just randomly think of a plan and give you. I have to analyze everything and I have to make the plan. Right? I wasn't able to do that because I was busy with doing other stuff about the webinar, I will give it to you on 30th. Okay, I'll give you my word for that. Can you suggest a way? Can you suggest a way to cover the syllabus easily after December? I'm not a science person too. Okay. Okay. Can you suggest a time and how to study with Okay, I'll definitely answer your question. Okay, on 30th. Okay, now these related questions like how to cover the syllabus easily after December and all of that. Now you're December students, no, not next month students, right? I mean, not you're not doing all of us next month, no. So for those people, I will make sure that I will give you all an answer to that on 30th. Okay. Yes, it is weird to be a modified. Yeah, no worries. Don't worry about it. Don't say thank you. Velocity time graph. Sure, because last I have to separate this thing for graphs. I will try to teach that, but that I don't know if I'll have the time to do that, but I will try. Okay, I will try. Okay, no, I can't understand how this Zoom works. There's so many messages here and there. Yeah, 30th also there is the webinar. I hope you have the calendar with you. Please check the group or the WhatsApp channel. There I have sent the calendar, I've sent everything there. So in that you can check on 30th. 30th is the last day. So I made sure it doesn't clash with other seminars, classes and stuff. But unfortunately, I think some seminars, famous search seminars, it clashed. But if it does, you can always watch the live stream. Okay. Okay, that's all. No, I this. Oh, sorry, it's the Azan. Well, Azan has finished in Candy. So if it's finished in Candy, it will finish in Kalam also, right? I have a doubt. Okay, it has finished. Okay. Right. Okay. So, right. If you have any technical problems, contact the admin directly. Okay. And if you have any other problems or any questions related to the webinar itself or anything about science, you can always text me. I'll put my number here. You can text me. Okay. Anything else? Talk to the admin. Okay. So the number and all it's in the group. Okay. Right. Okay. So if your friends are not able to join on Zoom, ask them to join the live stream, all right? Because some of them have problems in sending on WhatsApp to me, so tell them that. Right, now let's start the lesson, right? So even in the lesson, there's a few things that I have to say. So you all might wonder why I'm talking too much because that's how I am, okay? And sometimes I can get loud, I can talk fast. So if I do that, you can always ask me to slow down and I will slow down, okay? So now, if I were to talk to you about the topics. Now you all always ask me, oh, am I doing electronics? Am I doing that? Am I doing this? And all of that. So I clarified that to you. So now from the topics, there were two categories, right? Some of y'all, some of you all told that certain topics are hard and certain topics are easy. That's the reason I sent the form. Okay. So for most of you, what was hard was these three lessons. Okay. Most of you, this is 70% of the students, you all said was hard. Electromagnetism. Okay. Okay, I'll not write the whole thing. Electromagnetism. And the second thing was hydrostatic pressure. Now, the funniest part was I already made the tute. First, I made the tute, then I sent the form. That's how stupid I am. I shouldn't have done that actually. So next time I will not do that. So that's the reason. Now the tute questions and now the theory I'm going to teach, it's not matching kind of. Okay, so like I had a hard time doing like figuring out what to do. But anyways, let's see how it works, right? And the second thing was hydrostatic pressure, and the third one was optics. Okay, so these are the three lessons that you all told. The top three lessons that are hard. The easy ones were like forces, the Newton's law of forces, the friction, and all of that. The easy topics you all told were those, right? So it's not like I'm going to neglect the easy ones. The easy ones are actually your strength. Okay, that is something you all should know. Now, the easy ones, just because it's easy, you shouldn't neglect it. That also you must study while handling the hard parts. But in these last few days, I would recommend if you can mostly do the questions that are easy while also figuring out what the hard things are. Okay, try to tackle both. Okay, just because it's easy, don't push it away because that is your strength. Now, even we are doing questions, model papers and all, don't do now because some model papers, school papers like Royal College papers, that paper, this paper, they're hard, right? So now don't go behind those model papers, term test papers and all that, right? Try to stick to past papers because same as the past papers only you're going to get. Okay. So now I show you, I'll share the screen and give you an overview on how it is like. Okay. I will clear your doubts. Okay. I'll take some time and clear your doubts because when I'm looking at the doubts and looking at the screen, I'm losing brain cells. That's one thing. Another thing is, you know, it's hard that way. Okay. So I will clear your doubts if you want with doubts and all of that. I'll check it later. Okay. Right. So this is the paper of 2024 or 24. Yeah, which was held in 2025. Okay. So now, if you can see now the MCQ, now you would have seen this paper now. I don't know how many times you would have seen, but multiple times you should have seen this by now, right? So in this paper, the MCQs, I counted approximately they have given you 10 MCQs. Okay, approximately there are 10 MCQs, right? So from these 10 MCQs, they have been mercy, or like they have given you mercy, right? Because now, out of the 40 MCQs, they have only given you 10 physics almost, right? So that way you should know for most of you physics is hard. No, some of you only physics is like easy, right? For most of you physics is hard. So that way they have given you 10. So you should like, be able to analyze your papers. That's a skill that you should have. Take all the years of paper, go through and check like how many where does physics or chemistry come, but you don't have to check all the classification and all. But just to have an idea, you should be able to go through the like last 5 years of papers at least. Okay, by now you should have done them. If you haven't, it's still not late. Okay, so take like if you see the MCQs, there are around I would say 10. Okay, and those also it's very easy. Okay, it's not very hard. And then we have, these are for the December students who don't really know what the paper looks like. Or some of you all wouldn't even have seen a paper, right? So I'm showing you, right? So this is, you'll have part A, which is structured essay. So the first one is usually bio, right? Usually from biosphere lesson. And then you have, again, second question also bio. Okay, all easy, like it's very easy. And the third one is chemistry. And then you have fourth question, physics. Even when it comes to physics, they're not gonna, for some of you, it must be hard only, but it's kind of easy to tackle. Okay, creative questions. And then we go for part B, where it's all about essay. Okay, this is your best part. Okay, because you can write creative answers and you see the funniest answers also here. Okay, but I'm being sarcastic. Okay, so the fifth question is bio, sixth question is chemistry, and then seventh question is physics. This is entirely physics, a question that no one usually chooses. So if you choose this, you're awesome. Okay. And then the eighth one, to be honest, even I don't choose this. I go with bio because bio is like you know the answer. No, that's like I did something smart because bio I know the answer, right? But physics I don't know if the answer would be correct because you have to think on spot and do, So I avoid that. Okay. And then eighth question, A is bio and B is chemistry. Okay. And the ninth question is, sorry, the ninth question is A is chemistry. Oops, give me a minute. Yeah, ninth question, A is chemistry and B is physics. Okay, that is all. That also usually no one does. Okay, I'm not saying don't do what the majority is not doing. Okay, you do what is comfortable for you, because for some of you, your strength is bio. For some of you, your strength is chemistry. For some of you, your strength is physics. So you should understand what type of a person you are. That's how you get an A for science, right? You can't just follow the crowd and say, oh, because physics is hard for everyone, it's hard for me. No, right? So you should know what your strengths are by now. If you are doing O levels next month, if you haven't figured out what your strengths are, you should do the last 5 years of paper for all the questions. Like at least take 1 year paper, do the questions, essay structure, do all the questions, mark and see for which you're scoring the highest. From that, you can analyze. Okay, bio and strong is you choose bio, but you don't prepare before you go to the exam. Okay, but in your head you think, okay, I will do bio. But sometimes if you go to the exam, you realize bio is the hardest question in your paper, so that also can happen. So you should have backup questions and all of that. I'll train you on that on the 30th. Okay. So I'm not going into detail about that, right? So in these 3 hours, I'll be doing electromagnetism and hydrostatic. Okay, these are the two things that we'll be focusing on. And I'll be teaching you this in a very simple way. That doesn't mean I'm going to take the textbook and, let's do this practical, that practical. No, I'm not going to do that. I'm going to teach it you all in a very, very, very simple way. Okay. But, and also at the same time, I won't be covering every single corner of the book because I don't have the time. No. Now, 3 hours means in 3 hours I should finish. No. So usually, even qualified, experienced, awesome teachers, they themselves take like 1 month for electromagnetism, 1 month for hydrostasis. So how do you expect me to do in 3 hours? I can't do, no. It's not practical, So I hope you understand that point. But I will do the best I can to make you confident in these two lessons at least, right? And the others also, I just go around it and try to cover it up for you. Okay, do you have any questions about that one? Let me know if you have any questions about that one. I'll try to. And also, if you're asking about the break, I'll give you all the break. I'll give like 10 minutes, 15 minutes break in middle. Okay, so you can pray, you can eat, you can do whatever. For me, patta patta kashtam. Ennadu? What is hard? Okay, I choose 7. Wow, that's awesome. Physics is really hard. That's, I would say, it's your mindset. Okay, physics is not hard. Okay, because everybody, the entire crowd thinks it's hard. We also go with the crowd and we're like, oh, it's hard. It's not hard. It's very easy. I'll show it to you all in these 3 hours. Okay, as much as I can, but you all should be able to catch it. Okay, some of you all be there. You all will be there in the start of the session. Okay, and then when the session goes on towards the end, I'll count. You all are missing. So don't do that. Be there throughout the session. Okay, and take notes if you need. Current electricity, I will cover like here and there. Okay, so don't worry about that one. Yeah, all clear now? Recording provided. You can watch it on YouTube live stream. Blue screen is harmful. Yes, it's harmful. Okay, the way I'm talking is engaging and fun. Okay, nice, thank you. Okay, we'll proceed, right? Okay. Now about the forces. Now I'm going to start with a warm up, right? I won't jump into electromagnetism because I know it will be overwhelming because some of you all hate this lesson, right? This lesson is awesome, but you all hate it. So I'll go with forces, your easy part. Okay, so I'll take few minutes and forces in the sense I will not teach forces. Instead, we will do something nice. Okay, so basically, about forces, the Newton's law of forces, right? So if I were to talk about Newton's law of forces, how many forces are there? Can you all tell me? Newton's law of forces. Even if you ask a five, no, I don't think a 5-year-old would know, but if you ask grade 9 students, they might tell you, I think. So how many laws are there? Just tell me how many are there. Give me the count. How many? 3. Yes, there are 3, right? So there's the first law, second law, and the third law. So practically, okay, usually they will ask these questions in the O-level paper, right? They want to be merciful to the students. No, not like they want to, you shouldn't get mark, you shouldn't get it. No, O-level is made in a way that students can score very easily. That's the plot. Okay. So first law, second law, third law. So what is first law? Now, if you logically think, first law generally means what Newton is saying is if you don't move something, it doesn't move. That's what he's saying, right? But we think, but actually you can't write that in the paper, right? You can't now, just because I told you, can't say, Miss Zainab said, something doesn't move, that doesn't move, that's first law. No, right? Newton's law, he has given it in a nice way, Now, even if you all are becoming scientists, you all can discover something, but put it in a nice wording. If you do that, people will believe you and you can invent a law. Okay, I'm kidding, don't do that. But first law is actually until an unbalanced force is applied, okay, basically something doesn't move. That's what Newton's first law is. But there is actually a proper wording to it. But before that, I'll show you a meme, okay? A meme, it's a funny meme, okay? Just to make you laugh, maybe, if you're serious and worried about exam. So this is the meme I was referring to, right? Okay. So that's what he says, no? Like Isaac Newton, after discovering that, if something doesn't move, it doesn't move. That's what he says. Okay. So it's kind of, I found it funny. So that's why I'm sharing it with you all, right? So, anyways, that's about him. Now let's go and talk about you. Okay. So now, simply, now you can't really say what he said. Okay. You can't really say what he said. So we have to be smart. Okay. We can't do that, right? So, what the exact meaning or the exact definition of the first law is until an unbalanced force is applied. So I hope you have completed page number 17, right? Page number 17, okay? I'll screen share that also if you don't have the tune, but I have sent it in the group. I hope you have taken a printout. I'll anyways screen share it, but I don't think YouTube people can see it because my other screen is spotlighted. But anyways, you will have the tune with you now. So let's go and see this one. Yeah. Newton's first law, second law, third law, right? So I hope you have answered this, right? So I'm just jumping into that first so we can do like a warm up, right? So Newton's first law simply means until an unbalanced force is applied, okay, on an object. So you don't, you until you apply like a force to an object, it won't move, okay? If the object that is moving already will continue to move with a uniform velocity. If it's not moving, it's going to be at rest, right? If not, it's going to be at rest. So that is what Newton's first law is, right? Until an unbalanced force is applied on an object at rest will remain at rest, and objects in motion will continue to move in uniform velocity. It won't accelerate, right? You have to give it a push if you want it to accelerate or not. So that's the law, okay? In simple, you remember the mean, right? If you forget what Newton's first law is, that's the first law. Okay, so I hope you have written that. I'm not going to give you all time because of course, I'll run out of time if I give you all time. So try to think of it yourself and write it in your words and check the textbook and see, right? Let's go to Newton's second law. That's how you remember Newton's first law. Newton's second law is simply, remember this equation, okay? F equals ma. This is Newton's second law, okay? So now, in Newton's second law, okay, in Newton's second law, you have to remember this equation, okay? So acceleration of a body is directly proportional to the force. Now, basically, physics is like this, okay? It's logical. You have to understand it, but some things you can't think too much for your level. Now, your O-level students know. So that's why physics is hard for you. You don't know the reasoning behind the core concepts. Now, let's say now, even if I show you this, you're like, what is this? Why is it directly proportional? Why is it inversely proportional? You might have those questions. Why, what, how, all of that. It's reasonable. But for your level, we can't go into that deep, right? So that's why it's a bit hard for you. Now, if you just accept the fact that force is directly proportional to the acceleration and it is inversely proportional, right? Acceleration is inversely proportional to the mass. If you, I'll stop this. If you accept this, that I'm saying this, then it's going to be easy. So this is how we derive this. So according to maths, if you try to like shrink this together, it will be A is directly proportional to F over M. So instead of this proportional sign, okay, instead of this proportional sign, we're adding a constant and somehow making it like this, okay? And that's how you're going to bring the M on this side. F is equals to MA. That's how this equation came, okay? This is the Newton's second law, okay? So basically, if you're telling it in words, Newton's second law is acceleration of a body is directly proportional to the force and inversely proportional to the mass. Okay, that's Newton's second law. Okay, that's it. Nothing more, nothing less. And Newton's third law is even more funny because it's easy, right? So Newton's third law is if you push something, it's going to give you a reverse reaction. Now, just like how karma works, okay, and it's not about karma, right? It's not about anything, but I'm just giving you a way to remember, right? So when you do something, for every action, there is an equal and opposite reaction. You're going to get it back, right? That is Newton's third law. Let's say, but don't think about karma and say, okay, physics is karma. No, okay, that I just told to remember, right? Let's say a balloon. We talk about a balloon, right? So a balloon, how does it go up? It goes up because there is air coming downwards. Now, there is air coming from the balloon down. That's how it goes up. Same with a rocket. Now we'll say a rocket, right? I don't know how to draw a rocket. Okay, something like this. Okay, that's funny, but you know, there's something fire or something coming from down, right? So because of that effect, now it's going downwards now. That's how the rocket can move upwards. So basically, for every action, there is an equal and opposite reaction. Okay, so now what? Whenever I'm teaching, now I'm teaching this basic Totta Baba things. No, so until then, what you can do is, I would recommend now, if you haven't completed the tune, that is, if you have completed, I told you what to do. Color it, do whatever you want, right? And listen, okay, when I'm teaching. If you have not have asked you to bring full steps, no, some of the stuff there is no space to write on the tune. So write it on the full step. Okay, try to make a note on yourself while I'm teaching. Okay, and whenever you study, okay, you will come up, you will think, your mind will go in different directions. Like you will think about all the fantasies you're going to do after all years. So that is why I have given this space. When you're studying, soon take this, write it down, okay, and forget that. Okay, and what I said now was do the equations. If you're done with the equations, try to do the questions now, because most of you all are very smart. Okay, I'm being sarcastic, but most of you all are very smart, right? So for y'all can do this. Okay, y'all can complete as much as you want. If you haven't completed, if you have already completed, color and listen. Okay. Anyways, we will go back to it. Right. So that's about Newton's first law, second law, third law. Simple, done. That's it. Right. So there's nothing to think about now. Okay. So the next thing that we're going to talk about is go to the equations at one glance. So in the equations in one glance, okay, if you have done it already, then shape, don't think about it too much, right? I will also I have seen your doubts, okay? I will talk about it in a while. Oopsie. Okay, wait a second. So go to equations in one glance. So you'll have the PDF or the tube with you. Okay, here, right? So here the friction, right? Can you all tell me what is the equation of friction? It's very easy, no? It's not very hard, no? Can you all tell me? We'll see how many of you know the answer. I mean, even a grade 10 student, one who's sitting in December, can tell me the answer for this. Let's see. Okay. Can we write the laws in our own words or exactly what is written text? No, you have to write the same exact thing, because if not, Newton will cry from the grave. No, I'm joking. He won't cry from the grave. But the reason why it is a law is because you have to follow it. Now, even in the country, there are certain laws, right? You can't change the law. So law means laws. Now, whether it's Archimedes principle or whether whatever the law, you have to know it in the exact word. Okay, if you miss one word even, then there's a problem. Now we'll say in the Newton's first law, the until an unbalanced force is applied, bodies at rest will remain at rest. No, that at rest is needed, right? An object in motion moves with a uniform velocity. Uniform velocity is very important. As long as you have mentioned the keywords and it makes sense, that's what matters. But to be on the very safe side, law don't change. Don't change the wording. Okay, the same word has to be there. Don't change anything. Okay. Yes, very good. Right. So always there's a person. What's his name? Shrey. Right. He always answers physics questions in the paper. But I mean, don't take the risk if you don't know. Okay. Right. Yes. Most of you have sent the answers. Very good. What is the question? The question is page number 17 that we're doing. Okay. I think. Okay. I think I'll have to stop sharing. Okay. Most of you will have the PDF, right? Y'all have y'all have the PDF on your own. No, if y'all don't have the PDF, now I won't be sharing because the people on YouTube, they can't see it. Okay, they can't see it since. So we have to be good to them. No? So I will not share the screen. Okay. So they also have to see the board that I'm writing on. So please use the PDF, go to the group, take it, or ask the admin, she will send it. And also you have the hard copy, that's awesome, right? So I'll just tell the page number and we will move on. Right. Okay, so let's go on with the first page, right? 14, page number 14, right? So I'll just explain these frictions and type of friction. Or before that, I asked you all what friction was, right? Okay, so I will clear your doubts, okay? It's getting filled. I will clear your doubts during the break, okay? If not, I won't be able to do this, right? So now I asked about friction. What is exactly friction? So what is exactly friction? Or if I ask you the question, you might wonder, now, how can I tell it in words? What is friction? Now, when you're giving a force to an object, okay, let's say you're giving a force to an object, okay, you're pushing this object, okay. Now, just like how the Newton's third law is, when you give a force or when you do a motion, like this, there's gonna be another opposing motion. Now, you can feel it actually when you're pushing a cupboard or something. You can feel it's hard to push it at the first time itself, right? So that is what you call as friction, the opposing motion, right? So the force which opposes the motion of an object is called as friction. Okay, so if the direction of the force is this, the applied force is basically this, the friction is going to be in the opposite direction. Okay, yes, Rushdi, correct. It's the opposing motion. Now, when you're pushing a cupboard, now like I told you, when you're pushing a cupboard, when you first push the cupboard, isn't it very hard for you? So that is that point. When you're starting to push the cupboard, that start point is called as a static friction. When you can't push it at all, you're pushing it, it's heavy, it's hard. So the first time when you're pushing it is static friction. Okay. The moment it starts to move, okay, the moment that the cupboard starts to move, you can feel that this thing, okay. When the moment it starts to move, it becomes like a bit more heavy. You can feel the pressure, right? So that is called as a limiting friction. The moment it starts to move, okay, limiting friction. Okay, when it's moving now the cupboard is moving nicely. That time you don't feel the pressure much as limiting friction. That is called as dynamic friction. Now, dynamic, the word means it's like moving, that's what you call as dynamic. Okay, limiting it, it's limiting you from moving it, so it's like this has the highest force. Okay, so if I were to show you this in a graph, this is how it's going to look like. Okay, now this is the graph. Now, second, yeah. So this is the graph, right? I can't draw a straight line, but okay. So this is the static friction when it's not moving, right? This is the static friction. Now in your tube, right, in page number 14, right? Now y'all might ask me now what page am I doing? So page number 14, right? So here you can write what is static friction. If you know the answer, write it confidently, right? And then check your book and see. Now, anyways, I'll tell you what each of these are. Now I already told, try to write in your own words. If you have already written, then watch and wait confidently, right? And label this. Now I'm going to label it with me. You can label, okay? So this is static friction and this is limiting friction. Then obviously what is this? Dynamic friction. Okay, can you see that dynamic friction is kind of lower? It's lower than limiting friction, right? So limiting friction is when it starts to move. For that you have to give more pressure, right? The axis is very important. Okay, I forgot the axis. So the y-axis is frictional force and the x-axis is applied force. Okay, the force that you apply. Okay, you're applying this force, frictional force. Again, you might feel like, why can't this be here? Can't that be there? Again, that's not in your level of understanding, right? You might have so many questions on physics. Why is like that? Why is like that? Usually, you get the answer in A levels, right? If you're hoping to do science. Okay, so now you have to accept like it is what it is. Okay, so this is static. This is limiting. That is dynamic. Okay, so in sometimes in the papers you will have something like fs in small s. Dynamic usually is fk, right? The word kinetic or dynamic, you can use both, but we usually say in our syllabus as dynamic friction. Okay, so that's how it is. So if I were to say, no, static friction is a frictional force acting when there is no relative motion. It's not moving. No, that's, you have to say the word relative motion. Okay, when there is no relative motion, that's what you call as static friction. Wait, I'll write in different color. I have so many markers, but I end up using only black. Okay, right. So static friction, there is no relative motion. Okay, and limiting frictional force is when it just begins to move. I'm only writing the keyword. You write the full thing by memory. Okay, because if I spoon feed everything, you will get that this thing of waiting till I tell the answer, and you all will do. You all are doing exams in how many days, how many months? Sorry, not even months, right? It's just a month. So you all have to be able to write on your own, right? So dynamic friction is in relative motion. Now, even December people, you can do this, okay? It's in relative motion, it's moving. That's why it's less. This one, you don't feel much pressure. That one, you feel a lot of pressure when you're pushing. So that's how you complete that work. And friction, I told you, now go to the equations at one glance. There, friction, the equation has to be mu r. Okay, this is the equation. This is mu, this is r. So mu is usually you call it as the contact. Sorry, the coefficient of friction. Okay, the nature of the contact surface, right? Coefficient of friction. That means the surface. Now we'll say the box is over here. Okay, this surface, that one's coefficient is what you call as the mu. Again, you don't have to know what that is in detail. Just know that okay, mu r, right? R is the normal reaction. Okay, and mu is coefficient of friction. And I understand that in the equations of one glance, there might not be enough space, but most of the, not, I can't say all of it, most of the equations are here. The purpose of this is, so one day before your exams, now physics is mostly about the equations and stuff, now you forget it. One day before the exam, you can just take this and so go through all of this, right? Make sure that you do that. And every day or every other day, take this and go through it. You won't forget it. It will be there in your long-term memory. Okay. Make sure you go through this. There is, I think, two more that I haven't put here, but I will tell you all, right? Okay, so for now, include this under friction. Okay, friction, you can also, they also will denote it like this, FR, right? Okay. So, for now, let me know when you are done with the work. Okay, I think most of you all, I told you all to do it and count, right? So let me know if you are done. Send me a text message saying done. And if I'm fast, slow me down, okay? If we are in escape currently, can we go for an A for science? Actually, it's O level that we're talking about now. I mean, don't come at me for saying this. But if because it's O levels, if you had started even 6 months, 3 months before your O level, you could get an A. But now I can't really guarantee if you can go. But I'm not making you lose hope. You can, right? You still have a chance. If you put in the work that you have, put all your distractions aside, everything you can. There's nothing that you can't. Okay, if you can't do a certain question because you're not getting the answer, like we say an essay or something. Now, this also I'll tell the guidance session. Okay, a certain essay or something, you're not getting the marks for it. Don't choose that if you're not getting the marks for it. Usually, right? Sometimes I might miss your texts. Okay, and if you have the question stinging your head, send it to my WhatsApp. I'll reply to you all later. Okay. Yeah, I'll tell you what you have to do right after the session and all. Send me a text. Questions like that, send me a text on WhatsApp. I'll reply to you personally. Okay, because personalized, some people have some issues, some don't have that. Okay, anyways, let's move on to the next part, right? So now we'll go to resultant force, right? Now about resultant force, right? Oh wait, there's another thing, right? So about force in the same tube, right? Go to force and write the equation for that. Now I already told the equation. It's very easy. Soon write that equation and we can move on to the next one. That is simply F equals ma. So if there is no space on the tube for you, if you have like gundu letters like mine, you can always use a full stop, and maybe if you want to keep it neat and tidy, go to a full stop, write it, and maybe pin it somewhere here, then you can refer to it. No, right? Yeah, right. So now let's go. Oh, I forgot one part. Okay. Now, factors affecting frictional force. I will not go into detail. The factors that are affecting are usually the nature of the contact surface. Now, when you have an object, the contact that's in. Now, if it's a rough surface, it's hard. If you keep a box on a rough surface, it's hard to push. But if it's smooth, it will slide very easily, just like how skating and all of that you can do that very easily, right? If it is rough, it's hard to push, right? Friction is very high in rough surfaces. In smooth surfaces, it's very easy to push. That means friction is low. Friction is basically like a burden. It's like you're pushing something, but it's not getting pushed. That's the friction, mostly, right? The opposing motion, right? The other factor is, the first factor is nature of contact surface. What's the other factor? Can you all tell me? Give me an answer for the other factor. Now I'm going very slowly. I know this part is very easy for you all, but I just want to give you all a warm up, before we go to the actual part of the lesson, which is actual part of the session, which is electromagnetism. Okay, give me an answer. Yeah, surface area only, not surface area, nature of contact surface. Okay, surface area is something different. So what's the other factor I'm asking? What is the other factor affecting the frictional force? What is it? Okay, admin, can you please send the channel on the group, the channel link somebody is asking. So would you mind sending it, please? Tell me the other factor if you all know anybody. Yes, perfect, perfect, Bilal. Yes, normal reaction, right? So it's a normal reaction that is the factor that's affecting the frictional force. That's the second one. Normal reaction is equal to what? It's equal to the weight. So what is normal reaction? I'll go into detail about that, right? So normal reaction is, now we'll say this is the surface, right? So normal reaction is the one that's acting from here. Okay, oh, y'all can see, no? I'll erase this whole thing then. Give me a second. Okay, normal reaction. Okay. So normal reaction, I don't have to teach all of this to you all, but I'm still teaching. So normal reaction is the one that's happening from here. This is the normal reaction. Okay. Now you all might wonder why my object is floating, but just to show you all accurately. Okay. So this is from where the normal reaction acts. Okay. The mg or the weight will act from here. Okay. Mg. So normal reaction mg, if the object is like this, is going to be equal. Normal reaction is equal to mg. Okay. So when the weight increases, the more the weight increases, the more the normal reaction increases. So when the weight increases, the normal reaction will increase. When the normal reaction increases, the friction also will increase. Okay, so the more an object is heavy, now let's say you push, okay, I don't want to fat shame, but I'll just tell you, okay. If you're pushing a thin person, is it easy? Is it easy to push a thin person or is it easy to push a fat person? Whom do you think it's easy to push? Don't call me, don't tell them fat shaming and don't do that, okay? But can you tell me, is it easy to push a thin person or fat person? It's easy to push a thin person, right? Because a fat person, they have more, what do you say, a higher normal reaction, right? So more weight, more normal reaction, more friction. So you can't push very easily, right? So that's the whole point about that. Okay. So some methods. Okay. Now we say an object is very hard to push. Now we say this object, it's around 100 kilos or something. Okay. So it's very hard to push. So what we can do to make it easier to push is by doing this. Okay. We can either put some grease, okay, on the surface or somewhere. We can make the surface smooth, or we can put some grease, or maybe you can put some lubricant oil or something. That way, the object will smoothly slide over. That's one way that you can make the object to go fast. Another way, can you suggest me another way to move an object? What can you do to this object? Can you tell me? Let's keep it interactive and nice, okay? There is no equation for friction in the book. Friction is, you have no mu times r. Mu is the coefficient of friction and r is the normal reaction. So can you all tell me? Can you suggest me another way soon? Yes, very good, Bilal. It's inserting ball bearings, right? So if you put some, it's like it will become like a trolley. You put you fix some balls to this object, right? And if you push, it will smoothly go, right? So this is another way that you can avoid the friction, right? Now let's say another way, right? Let's say that you want friction. Now let's say that already now this object is going super fast. Now let's say this is a very it's a snow place. Okay, let's say this is in Canada or somewhere, and now it's very slippery. Okay, let's say this place is very slippery, and okay, let's talk about your shoe or something. You're gonna slip now. Okay, so if you're going to slip, what can you do to prevent? The first thing that you can do, I would say, is use a proper shoe with grooves. Grooves means that's why people wear boots and all, right? Grooves means like under. Now, if you take the down part of the shoe, you have like one design, right? It's not actually design. It's to prevent you from slipping. If your shoe is flat, you will slip and go like that to heaven, right? No, not to heaven, but you will slip and go, right? So that's why there are like these one designs like things, so you won't slip. Okay, so even in the snow or these places, the ice places and all, so you won't slip. You have this grooves underneath. Okay, so that way you can actually increase the friction. Okay, so these are the two ways. That's the purpose. The whole purpose of friction is the uses of friction would be to walk. Because if there's no friction, you can't walk, right? You will just glide through the or glide on the surface, right? You can't swing, and even for the ropes and all, you need friction, right, to make ropes. So that's all I would say about friction. Okay, did you understand that? If I give you now, that's like very very basic. Okay, the whole chapter is summarized in, I would say, I don't know how many minutes, but that's it about friction. Let me know if you understood. You have any questions? And about other questions, now let's say, Miss, can I get a plan for that, plan for this, and all that? Send me on WhatsApp, okay? I will clarify that personally. Yes, supply boric powder. Yeah, all of that, right? Understood. Okay, I'm moving on then. So many of you have understood. Okay, right. So I'll leave the resultant force part now in the same tube. I have a part called resultant force. I took so much time on the friction, so I'll leave this part because this part is comparatively easy, right? So I'll leave that and let's jump into our main part of today, the highlight of today, which is electromagnetism. For that, I haven't allocated a separate part on the tube. Okay, we have questions though. Here and there, I have put questions. That is once I've done the no, I mean teaching the theory. Okay, so what I would want you all to do is take a full step. Now I asked you to come with full step extra papers. No, so I'll be teaching y'all. Y'all can make your own mind maps or whatever summary charts or whatever while I teach in a way that you like. Okay, so that will be useful for your exam. Okay, let's jump into the lesson, which is electromagnetism. And I have something fun prepared for y'all. Okay, I'll just give you all a glimpse of that because I'm more excited than y'all are. So I have this stuff. I got it. So this thing and this thing. Okay, so let's do this at the end. Okay, if I will have time because I have to make time. So let's do all of this at the end. So wait till the end. Okay, if y'all go, then colors. Y'all won't have the experience. Anyway, so let's start. Now, electromagnetism, let's go into that part. If you have any doubts in the meanwhile, you can ask me. I will clarify it for you. Yeah, so now I'm going to jump into the lesson. It's really nice that you're very active. Yeah, after the lesson only I'll be dead. Okay. It's nice that you're all active more than me. So it makes me feel active. So that's what I prefer. Okay, so now let's go. Now, if your friends on YouTube, ask them to join on Zoom. But if it's hard for them to join on Zoom, it's fine to join on YouTube. But only thing is, YouTube, I can't really interact with y'all. So that's why I prefer if y'all join on Zoom. Okay, so let's go to the main lesson, the highlight, which is electromagnetism. And as for the break, I'll give you all a break once I finish electromagnetism. Okay. So it's not very hard. Now, you all might think when I finish electromagnetism, it will be tomorrow morning. No, it won't be because I am summarizing it, making it very short. So I'll try to do the best I can. Okay. And you all have to cooperate with me and try to understand the best you can. Okay. So let's do it together. Now, in electromagnetism, okay, there are three concepts. Okay. Core concepts of the lesson is only three things, nothing much. That's it. Okay. The first thing is you all can do something like this. Now, I don't have space on my board. For that reason, I will write it like one by one. Now, if I'm talking about magnetic field of current, I'll only write that. But what you all can do is take your paper and so you all won't be bored. Okay, take a paper, draw a table or a chart or something and divide into three columns. Now, I said three core concepts. No, so in that three core concepts, write the topics. Now, when I say one, two, three, you write it like this, and underneath you make your own chart. You write it whatever I'm saying in a way that you understand. You write, make it colorful. Take your whatever color pencil, that thing, this thing. You make it colorful. But just because I'm saying to make it colorful and nice doesn't mean you all don't listen to me and you all just bada copy what I'm putting on the not like that. Okay, understand what I'm saying and try to write it. If you want, you can just write it in a messy way now. And after the class finishes, if you have time, you can write it nicely. That also you can do. Okay. But if you're a person who can focus only and not write, then focus. Don't write. Okay. Do what is easy for you. And I'm going to start. Now, now we will start with the first core concept, right? So there are three core concepts of this whole lesson. The first one is magnetic effect of a current. Magnetic effect of current. Okay. The second one is magnetic force. And the third one is electromagnetic induction. Okay, I'll just write as electromag. Okay, are there space? You can see now. Okay. Electromagnetic induction. So these are the three core concepts of the whole lesson. That's it. There's nothing else. Okay. I will start now. I hope you have put this as the topics in your or the column topics right on your table, right? So I will go first with this topic. So basically, what this is saying, okay? Now this magnetic effect of a current is proposed by a person, or there's a person who comes with this and he says, I think there is something like this happening. Okay, magnetic effect of a current Kayla, there is something it says. So that person is coming and telling you, proposing this idea. And his name is called Hans Christian Oster. So you must know this name. Okay, they can ask you, but I don't, yeah, there's a chance they can ask you, but mostly there are other things to ask, but you remember this, okay? Hans Christian Oster. So it's also called as Hans Christian Oster law. Okay, this is his, he only proposed this specific idea. Okay, I mean this specific law. Okay, so what is this law saying? When there is a electric current flow through a conductor, now let's say this is a conductor, this is a wire. Okay, now there is a current that is flowing through this conductor. So definitely, he's saying definitely when there is a current flowing through this specific conductor, there is going to be a magnetic field around it. That's his idea. That's it. Now we'll say this is a wire. Okay, I have a wire with me anyways. My electricity, I mean the circuit might go upset. So I just not. But let me just check. There's a wire, but you can't see anything. Anyways, so around this wire, okay, there is going to be a magnetic field. It is. That's what he's saying. Okay, that's it. That's his law. When there is an electric current flow, when there is an electric current flow across a conductor. Now, this is the conductor. There is an electric current flow. So, in return, what is happening? There is always a magnetic field. Okay, that it is producing. Always there is a magnetic field. That is what he's saying. Okay, now it's not about him just saying and going, without explaining to us how to find and all of that. No. So he tells this concept. Okay, and he tells there is a rule to find the direction of it. There is a rule itself. So the rule that he says is the Maxwell corkscrew rule. Okay, there are two rules that you can use to find the. Now we'll say the current. Okay, and you have to find the magnetic field. Okay, you know the current, you have to find the magnetic field. Then you use this law. You know the magnetic field, now you have to find the current. You use the same law, right? So you can interchange and find it. Okay, somehow in the question, if they ask you, now this is the electric current, find the magnetic field, Kiela, then you have to use this law. The two laws are actually, the first law is the Maxwell corkscrew rule. Maxwell corkscrew rule. Okay. And the second one is the right hand grip. I mean, it's the same thing. Okay. I won't say second one. I would say the same thing. I'll just put as O and right. Okay. And the second one is the right hand grip rule. Right hand grip rule. So how does this work? I'll tell you now. Right. So simple. Okay. It's nothing hard. Okay. This is Maxwell corkscrew rule or right hand grip. Now, have you all seen a corkscrew? Can you all tell me if you have seen a corkscrew? Yes or no? People who have seen a corkscrew, raise your hand. Let's see how many of you have seen a corkscrew. Let's keep it interactive. Okay. Have you all seen? Because I'm going to show you all. I don't have one with me, but I can show a picture. Okay, okay, many of you have seen, right? I'll just show a picture. Give me a second. So this is how it looks like, okay? Give me a second. It's opening. Okay. If you haven't eaten, if it's not disturbing for you now, if you're someone who can eat and study, then you can eat and study. But anyways, I'm giving a break, okay? So don't worry. If not, don't eat it and study if you can't focus, right? So this is a corkscrew, right? This is a corkscrew. It's used to open wine bottle and stuff. So don't ask me how I know. I have never opened a wine bottle, but this is how it is used for. Now, if I show you a proper picture, let me show you that also. How it is there. Let me show you. Yeah, there's another picture that I saved for y'all. This one. Okay, this is the corkscrew. Now, if you see, this is the corkscrew, right? Now I'm going to show you how why this person said corkscrew and how is that related to this, right? I'm going to show you all now. Okay, I'm going to tell you all now, right? That is exactly a corkscrew, right? So this is how you do it. Now you take your right hand. Now this is my right hand. Okay, wherever you are, take your right hand, right, and this way, right? This is how it is, right? So right hand, sorry, Maxwell corkscrew rule. Now it looks like a corkscrew. Now if you do this, it's a corkscrew, right? The down part of this and this top part. This is what you do, right? To find the direction. But let's say the current is going now. I can't do like this, so I'll change the direction a bit. Let's say the direction is this way, right? So I will do like this, and if I do like this, you know, this way and like this, right? That way you can find the magnetic field, right? The current is this way, magnetic field is this way. So that means the magnetic field is going like this. Okay. So sometimes in your book, I mean in your paper, they will not make you draw these stuff like this. They will ask you, is it into the page or out of the page? They will ask you a question like this. Is it into the page or is it out of the page? Okay. So how can you really figure out if it's into the page or out of the page? So I'm going to show you that now, right? So now let's say an arrow is being pointed towards you, right? I will just take an idea of an arrow. Let's say an arrow, you use bows and arrows, you know that, right? An arrow. So this is the point part. This is the cross part. This is something my teacher told me. This is one way that you can find, right? So when an arrow is coming towards you, what can you see? Can you see now this is the arrow. Okay, this is the pointed part. Okay, this is the cross part behind it. Okay, wait, I think I put a cross. Let me just show you. Here. So let's say this is the arrow, right? This is the tip of the arrow. This is the cross of the arrow. Okay. So let's say it's coming towards you. What can you see? Can you see a dot or a cross? What can you see? Tell me. Let's keep it interactive and fun. Some of you are already missing. Maybe you all went to sleep, no? Or maybe you all are on YouTube. Yes, it's a dot. Ask your friends to join, okay? If they're on YouTube, then they just have to watch. No, there's nothing that they can do. Because in Zoom only we can talk and we can have fun. Okay. And don't take it personal when I'm not replying, okay? Because Zoom is, I don't know, they have changed the update now. I have to go to each of your chats to check what was sent. So it's a bit hard for me. That's the reason I can't really, but I'm looking at what you all are saying, but I can't really reply to each of it. So if you have like, you know, what do you say? If you have very, very lengthy questions, text me personally. I will reply to it later, okay? Right, so you can see a point here, right? So you can see a point here. So when it's coming out of the page, we denote it as a dot. Okay, so if it's out of the page, you denote it as a dot. So it's like it's coming like this means you can see a dot. Okay, so think if you forget it, what is out of the page into the page, take your pen in the exam, take your pen and see. Remove the lid, take the pen and see. If you bring it close to you, you can only see dot, right? So it has to be out of the page. So a dot means usually out of the page. Okay, what is a cross then? It's going into the page. Now cross means it's going into the page. Cross is going away from you. Cross means into the page. Okay, cross means into the page. Okay, out and in. So that's how you denote. Now if you don't know, that's how it is. No means because alcohol is haram. Yeah, I'm aware. I also know that alcohol is haram. I haven't had, okay, but I know it because I know it. Okay, right. Yeah. Okay. So that's about this. Okay. So know this out and into, right? So in this scenario, as of now, you can see that it's going now. You can't really say out or in because it's like 3D. No. So here, how you can properly say is you can say if it's clockwise or anti-clockwise. Okay. Now for this scenario, now let's not apply this. That's one. But remember, okay, we need that in the future. Now when you look at this, you can see the circle is like this. No. take one circle separately. It's like this, no? Is it clockwise or anti-clockwise? If I ask a grade 5 student, they'll tell me. Is it clockwise or anti-clockwise? How is the magnetic field like? Tell me, clockwise or anti-clockwise? Come on, don't sleep, okay? If I'm boring, tell, okay? Clockwise. Oh yeah, it's clockwise. Okay, clockwise. Yes, yes, it is clockwise. Okay, it's going in the same direction as the clock, no? 12, 1, 2, 3, 4, 5, 6, 7, 8. So it's clockwise, right? So this is clockwise. Okay, so that way you can say, oh, it's clockwise. The magnetic field is happening clockwise. But there are other scenarios where we'll have to use into the page, out of the page, so we'll come across it in a while. Okay, so that's about that. I've not spent so much time on that. Right? Same thing with the right hand grip rule. Use the right hand. The Maxwell Cross also you use like this, no? Right hand grip rule is same way. This way, like this. Right? This way, like this. Don't change your hand, okay? Always use your right hand for right hand grip rule. I'll tell you where you use left hand and all in a while. Right? So right hand grip rule. Okay. Right. Let's move. So the other thing is, we will go now in this scenario. Okay, what's happening here? Now, magnetic effect of a current, we're usually discovering from an electric field. Now, he already said, no, if there's an electric current, there's going to be a magnetic field. So the energy conversion here, can you predict the energy conversion here? The energy conversion here, now you all take some time to reply, so I'll list it here, okay? The energy conversion here is electrical energy. So I'm giving a short note, okay? By the end of it, you're going to have an awesome short note. So it's going to convert electrical energy to what? Magnetic energy, okay? So there's going to be a current flowing, electrical energy current flowing. So by that, it's going to produce a magnetic energy. So that is it about the magnetic effect of a current. So you can do any questions from that, you will figure it out, right? That's all, right? In your textbook, if you want, you can check that for further details. For now, that's it. Okay, so now let's go to MCQ number 10. Take your tutes and go to MCQ number 10. And can you all try it out? If you have tried, can you all tell me the answer? MCQ number 10. I'm looking at your chats, okay? Try it soon and tell me the answer. MCQ number 10, page number 18. MCQ 10, page 18. And also here, don't leave the meeting thinking I'll watch the recording later or I'll watch it on Zoom because, sorry, on YouTube. You will never watch it. Okay, that's the truth. It's gonna pile up, pile up, pile up, pile up. The hard reality is you will never watch it. Okay. So what's the answer? Yes. Ibrahim, correct. I don't know if that is, oh yeah, it's Ibrahim, no? Miss, I don't understand what is out and into the page. Okay, I'll explain that again. Clockwise. But the others might be wondering, now I understood that, no, again, she's going to teach. So for people like that, go on answering the MCQ questions, okay? Break at what time? Now only we started, no? Break, I'll give once I finish this, okay? Because if not, we won't finish it now. I'll give you a break, don't worry about it. At around, let's see. Answer 4, correct. Mushfira. Sorry, I told the answer out loud. Okay, so it's the fourth answer. Let's try and see now. Okay, so most of you have done the question. So I'll proceed. I told you to answer it and come anyways. So let's try it together now. Okay. Now in this question they have told, right, diagrams given below show the magnetic field formed around a current carrying conductor or current carrying wire called AB. Right. So now in the first one, it might not be clear, right? So first one, they have told the current, it's moving this way. The current is moving this way. And they have told this is a dot and this is a cross. The second one, they have told something like this. Now, by this, I'll teach you what is into and out of the page again, right? So I'll show you that. If this is the first time you're studying, you might have doubts there, so don't worry about it. But for the people who have already studied, it's a revision for you all, right? This dot and this is cross. Okay. And the other one is this way, this way, this way, cross, middle. Okay. So now, if you try it, now right hand, now you have to use Take your right hand, now you keep it on the screen, wherever, phone or whatever. So you do this and check, right? Now this way, now here, now you're going into, right? So we learned that if you do it this way, okay, always check first before you start your paper. If you're forgetting this often, try to check and see. This is means now if you see an arrow coming towards you, you can only see a point, right? This is a way to remember, okay? So this is how in physics you denote. If it's a point, it means it's coming out of the page. Okay, if it's going in, okay, if I show you my other marker, in, okay, is going to be a cross. Okay, so this is how it is. Now here in the question, they have given you like this, and this is how they give for the exam. They won't tell you if it's in or out, or they won't show you like, you know, like how I showed you earlier, anti-clockwise, clockwise, they won't show you, right? So you have to understand this is out, this is in. So in our scenario, now if it is going like this, not forget this, right? I'll write it here. It was like this, no? Check and see, right? Right hand, do it this way and check. What is this? This is in, right? So if it is in, it has to be a cross. And the other way, when you're coming out, okay, it has to be a dot. So is it matching the one they have given? Is it matching? No, right? It's not matching. So this is completely false. This is wrong. So you can't consider this as an answer. Okay, so let's go to this one. Okay, so this one also use the right hand and this way. Okay, now again, not to confuse you all, I'll write the answer that they have given on this side, cross and a dot, right? So if you do it like this is coming out of the page or out of the board. Out means what? Dot, right? So dot means like this. Because from here it's dot. When you go other side, it's going to be a cross. Okay, it's a cross. So is it matching our answer? Is it matching? Is it matching? No, it's not matching. So that is also wrong. Okay, I hope you understand. The one who asked the doubt, I can't remember who asked it, but now I hope you understand what dot and cross is, right? Dot means it's coming like this out of the page. Now, if this is the page, it's coming out. If it's going like this, it's going into the page. Okay. So if you want, try it on the exam and see if you're getting confused. Right? So the same thing here. Now check and see. I'll again write this out for now so it doesn't confuse you. This is the answer they have given us. Let's see if it's correct. Okay. It's going like this. Okay. It's coming out of the page. So out means what? It's a dot? No, it's a dot. Okay. Like this, if it goes, it's going into. So into means what? It's a cross. So this side is going cross. Okay. So it's matching, right? The one they have given, the answer they have given, and the answer we found. It's matching. So therefore, this can be taken as an answer. C is correct. Let's see D now. Okay. So they have told cross and dot here. So now this way, like this, like this. So this is in. In means what? In means a cross. In means a cross. And the other way it's coming out is a dot. It's matching, right? So the answer they have given, the answer we found is matching. So that is correct. C and D, the answers are correct. So that's why C and D. So C and D only, answer number 4. So the ones who got it, very good. Okay. But usually for the exam, they give these kind of questions only usually. So that's like the basic ways of doing the question. Okay, so that's about it. Now let's go into the magnetic force. Now if you're hungry, okay, you can eat now. I don't mind. Okay, as long as you can focus and eat. Don't go and have a biryani now while I'm teaching, okay? Because I'll also be hungry, now. Think about me also. Okay. So like eat something light if you're eating and listen to me, okay? Because I can't really predict what time I'll be able to give the break. But let's see, inshallah. Okay, let us proceed now. That's about magnetic effect of current. Let's go to the next column, which is the magnetic force, the second core concept. Okay. The second core concept is about magnetic force. Now, magnetic force, okay, simply, this is the second core concept. In this core concept, what we are going to learn is simply this, right? Here we are going to find the force. The suspect here, or basically the person that we are going to find out, is going to be the force. So in any question, if they ask, find the force or something like that, it usually comes to this. If you compare this and electromagnetic induction. For now, if you didn't understand what I said, it's fine, leave it. You will understand it when I explain it. Right? Okay. So now let's talk about this. Now, when there is a current carrying conductor, same thing, right? So everything is about current carrying conductor. The word electromagnetism, okay, I forgot to explain that. Electromagnetism means it's basically something to do with electricity, and magnetic. Some relationship. Sorry, you can't see, no? So you can see, or can't you see? Let me see where. Anyways, I'll avoid writing there because I don't know if you can see, no? I'll go with the bottom. Right. Ivalo edam vechikunda, I went up, sorry. So electromagnetism, um, this is electricity and magnetic. Okay. These two coming together, it's like a collab. Okay, it's like a partnership, like a thingy, not partnership, but in physics terms, it's like these two coming together. By magnetic, sorry, by an electric field, you make a magnetic field, right? I'm stuttering also. From an electric field, you make a magnetic field. You have something like that. From magnetic field, an electric field is produced. Something like that. There's a relationship between these two. So what that relationship is about, this chapter is. If I were to explain to you in simple terms. Okay, that's it. It's nothing hard. You're just complicating it for no reason, right? So now, if we talk about the magnetic force, so when there is a current carrying conductor, there is a current carrying conductor perpendicular to a magnetic field. So you all know maths, no? You all know maths better than me, right? So electric conductor, there is a current carrying conductor perpendicular to magnetic field. So what is a magnetic field? So it's like this. It's only perpendicular. So you know maths better than me. So I'm assuming you know what perpendicular is, a 90 degree. Okay, so if it is like this, apparently, okay, somehow by some miracle, there's a person who discovered this, a person called Fleming. Okay, he was like, if there is a current carrying conductor this way, I will put the direction right. There's a current carrying conductor this way, current, electric current, and there is a magnetic field that is perpendicular to the current. Apparently, there is going to be perpendicular to these two. There's going to be a force, it says. Okay, perpendicular to these two means it's going to come like this out of the board. Because this way, if I were to, sorry, if I were to like turn my board the other way, you would see that this is a 90 degree. This is a 90 degree. You can see, no? Yeah, this is a 90 degree. So I can't really draw 3D. Okay, I can't really attach my marker here and teach for the rest of the time. So I will just say like this, something like this. Pretend like this is coming out of the board. Okay, it's coming towards you. Okay, so there is a force that's going to come perpendicular to these two, the electric current and the magnetic field. Perpendicular to these two, there's going to be a force that is coming outwards. Okay, so that's the whole thing that magnetic force is about. You're going to find the force for everything. You're finding the force. For this also, there's another law. I'll tell you all what that law is. Okay, if you know the law, can you all tell me? Whoever who has studied this, can you all tell me the law? Are you all there? Are you all sleeping? Yes, Faraday. What? Faraday's law? No, not Faraday's law. Are y'all there? Can y'all tell me soon, soon? And y'all are there. Y'all are sending me the chats. I'm trying to figure out. Yes, correct, Ibrahim. Correct, right? So it is Fleming's left hand rule. So people who are on YouTube, I would recommend y'all to join on Zoom because I don't know what y'all are doing there. So it's better y'all join on Zoom. Okay. Fleming's left hand rule. Okay, so now y'all are confused. I know the confusion all of you have. Fleming's left hand ruler, right hand ruler. So you'll have that confusion. No, I will clarify it now, right? Fleming's left hand rule is to find the force, right? Fleming's right hand rule is to find the current. That is not here, right? Current is going to the electromagnetic induction part. So don't confuse that. For now, just remember Fleming's left hand rule here. Okay, we're finding the force. Fleming's left hand rule. It's right. Okay. Now, this force that is found. Okay, I forgot to say this is current. So I hope you all are making a mind map or the chart, right? So I'm assuming you're not doing so. And this is the magnetic field. Once you are done with the mind map, send me photos, okay? send it to me personally or send it to the study group. Others also can benefit, no? Right. So Fleming's left hand. Okay, Fleming's left hand rule is what we use. So now this force, I will tell you what Fleming's left hand rule is, but for now we will keep this aside and go to this force. Okay. Now this force, it depends on three factors. Okay, three factors. So this is also something what my teacher taught me. I'm teaching you all. Okay, so it's like passing knowledge. So if it's the three factors that are being dependent on this force would be will, not brother-in-law, right? Will, which is B is the magnetic field, okay, and I is the current, and L is the length of conductor, okay, the length of the conductor. So these are the three factors that this force, this said force, depends on. BIL, magnetic field, current, and the length of the conductor. Okay, right. Now let's go into detail. Okay, now this magnetic field and this current and this length of conductor. So basically, you have to know this equation. That's it, right? Nothing else. So these three factors have to be perpendicular to each other. No, I did not draw that. No, the perpendicular like this. It can be how else? Like this. I can't really draw the 90 degrees, but I hope you understand. It's coming out like this. Okay. In the paper also you can't draw this. That's why we draw it like this, coming out of the page. Oh, you can even draw it like this, coming out of the page, no? Like this dot. Okay, something like that. Right. So that's about that. Now this is used in. Can you tell me some uses of this? If you know any users that if you know, can you tell me? I will tell you what Fleming's left hand rule is. So it's like I'm going in detail, okay? Like pretty detailed. Or even Shuraim has told me. Sorry, okay, if I didn't see your answers. I have 62 messages. Wow. Yes, yes, Ibrahim. It's in the DC motor, right? It's in DC motor. It's in the loudspeaker, galvanometer, ammeter, voltmeter, all of those things. You use this. You just know the users. Just remember the users, right? Loudspeaker, DC motor, and all of that. So basically, the energy transformation that's happening here would be now in the DC motor. How is it? Using an electric current, you're producing a mechanical energy. The motor usually rotates how using a current. No. So the transformation of the energy would be electric current to mechanical energy. Mechanical energy means potential energy, kinetic energy. That's what mechanical energy is. So that's the energy transformation that is being used here. Okay. So I'll tell you what the Fleming's left hand rule is. So you take your left hand, now not the right hand. Now the problem here is in your exam you get confused. Is this right hand or left hand or what hand or what? So that's why I'm saying if you're finding the force, always you use the left hand. Okay, always use the left hand. And in your left hand, you should know that it goes like FBI, not FBI agent, but I'll tell you why that is that. Okay. So we take right on your hand, on your fingers, please write this. Okay, F over here. I can't write now. F B I. Okay, something like this. So this way, use the left hand, okay? Don't use the right hand because right hand we're using for something else, okay? So now here using the FBI rule, now we'll say the current is going this way. Current is going this way, magnetic field this way. Now I told you correctly, right? The force is going to come like this. Oh, sorry, wait, what did I do? FBI. So, oh, sorry, current is like this. Sorry, okay? I did the wrong thing. So I is the current is like this, magnetic field is like this, the force is coming out of the page. So you have to correctly do. Now, just like how I did earlier, that's wrong. No, I got the correct answer, but it's still wrong, right? You have to understand. Now, you have to keep your hand fixed like this. It's like yo-yo. Okay, I mean, okay, I'm kidding. Okay, I'm just saying it as a joke. But like, you have to always keep your hand like this: 90-degree here, 90-degree here, 90-degree here. Okay, this way, keep it fixed. Okay, and if the question is given on the book, keep it on top correctly, right? I means don't change your fingers like this. Keep it fixed. And I is like this, magnetic field is like that, and the force comes out of the page. Understood? So that's how you do it. Okay. In questions also same way. You're starting hard. Questions also will be simple. So if they ask you to find a force, you go with the Fleming's left hand rule. It says FBI. F means what? Force. B means what? Magnetic field. I means what? Current. If you have other mnemonics other way, you can follow, right? This is just the way that I remember. So FBI is the way I remember, right? So in any question, if you find the force, this is what you apply. Okay, right. So now that's about that, about the magnetic force. Simple, right? That's it. You can understand magnetic force. Any questions, any doubts? We have to talk about DC motor, yes. But once I complete electromagnetic induction, the briefing, we will go with the DC motor and other stuff. Okay. But I think before we go to DC motor, I'll give a short break. If not, you all will annoy me again and again asking for breaks. So I'll give you a short break and we'll go with DC motor and then let's go to hydrostatic pressure. So I can't really assure if I can cover the other areas because I'm not a robo, but hopefully I'll be able to do so. Right? Let's see. Please, again, what do you want me to do again? Can you repeat? Loudspeaker. Yeah, loudspeaker also can be taken as this as an example for this, where there is a current and there's a magnetic field and there's going to be a force. So loudspeaker is also one example that we can do, right? In your book, it's there in detail, okay? But I can't really go explain in detail. I might take days and days to do that. So I'm teaching you a very short way where you can make your own mind map and stuff, right? It will be useful for you later on. Sorry, Tejani, now I saw all your answers. So it's like the chats are separate, right? Yeah, yeah. Oh, wait. Somebody has begged me to start electromagnetism and she has left. Oh my God. Okay. Okay, right. Now I'll continue, right? We will continue with the this thing. So that's about magnetic force, right? So now we'll go into electromagnetic induction. That's not the only thing, okay? In the book, you have, if you want like an elaborative explanation, go through your book. Now, once this session is over, this is what I'm teaching you in a simple way. You know? So I would prefer, right, if you go to your textbook and try to read it on your own and try to understand, right? Now, I'm teaching you in the shortest way possible. So in your book, it is there in detail, right? So go to your book, try to find the this thing. And if you have any questions, please do ask me, okay? I will clarify to you personally. Any other doubts too? Next, let's go to electromagnetic induction. And if you can understand something, please directly ask me, okay? I will clarify to you. Only thing is I can't figure out how this message thing works, but I will. I'm there in your chat so I can see it. Okay. So next thing that we're going to talk about is electromagnetic induction. I know physics is boring, okay? I will agree with you, but I'm trying to make it as fun as possible. I will even be showing some videos if I can. I have planned to show you videos and I've also planned the circuits and stuff, so don't worry about it. That's how you learn physics. Okay. If you can understand the concept, you always have YouTube. You're not in Palayakaram no, where you don't have anything to, you have to go to the library to find the books and find what is there. No, you have everything at your fingertips, right? Take YouTube, take ChatGPT. Okay, I don't recommend ChatGPT, but if you don't know some questions, like if you can't understand it at all, use the AI tools that you have, ChatGPT, Gemini, and all of that. Use it and use it for the best way possible. Okay, and like use YouTube and all. Try to find videos and study. Especially for bio, you can study through videos a lot, right? That's my recommendation. So let's go with electromagnetic induction. Okay, right. So electromagnetic induction. I think someone told me before Faraday's law. Okay, for magnetic force, you told me Faraday's law. But no, Faraday's law is this. This is only Faraday's law. Electromagnetic induction is only the one that was brought forward by Faraday. This is only what we call as Faraday's law. The previous one, the magnetic force, where you find the force, that is by Fleming's left-hand rule. So in this scenario, this is electromagnetic induction. What is induction? Induction means you produce something. Induction, you induce something. You know, to plants or you induce something. The word induction means you produce a current. Okay, you produce a current. Now, induction in this scenario is you produce a current. That's what you mean, induction. Okay, so in this, using this Faraday's law, what we do is when you want to find a current, you use this law. That's simple. The previous one, when you want to find a force, you use that law. In this one, where you want to find the current, you're going to use the electromagnetic induction. Okay, so this electromagnetic induction, there is a popular question that they can ask you in the essay. The question that they can ask you is, what is electromagnetic induction? Now, I won't ask you all personally because it's pretty long. So by the time you're type, it will be tomorrow morning, 5 a.m. probably. So I will not ask you to type, right? So try to say it with me, right? So it basically means this also is Faraday's law. You can't change the words, right? So try your best to write in the same possible words. So how you can know physics is annoying because you have laws, you have a lot of things to, the concepts that you have there, you have to memorize mostly. But the rest of it is application. So the memorizing part is the hardest for all, like the equations, the laws, and all of that. If you know those basics, everything else is solvable, right? Okay, so now if we talk about the Faraday's law or the electromagnetic induction, it means basically you're going to produce a current. Okay, produce a current. How are you producing a current? Let's see now. I'll erase the topic also. How you're producing a current is when you say, now let's say a conductor is kept at rest. Now it's always about a conductor, a wire, conductor, something. Okay, it's kept at rest. Okay, in a changing magnetic field. Okay, let's say a magnetic field is being changed. Okay, let's say you're changing, that means you're putting bring so many magnets close to it or something. Somehow there is a magnetic field is being changed. Or you send this conductor in and out. How you change the magnetic field? There are three ways. I'll tell you that also, right? You bring the conductor in and out of this magnetic field. This is the magnetic field in red. Okay. If I'm fast, you can ask me to slow down. Okay. I will not take it. I will not be hurt or anything. You can tell anything to me directly, but don't hurt the other teachers. Okay. Please. They will not come again after that. Okay. So this is the conductor, the electric conductor. Okay. This is the electric conductor, the current carrying conductor. I'm sorry. The current, I'll just put as current here. Current is going like this. Okay. So this is what is happening. So there are three ways how you can change the magnetic field or the current. So either you're moving the current carrying conductor, that's one thing. Another thing is, okay, not a current carrying conductor, let me just say conductor. Don't say current carrying conductor, any conductor, okay. As long as it can conduct some current, the conductor is there, a wire is there, and then you're keeping a magnet close to it. Okay, if I want to show you, I'll have to take it out. So never mind. So we have a conductor, we have a magnetic field. You move the magnetic field, and the conductor is remaining steady. It's there. Conductor is there, you move in the magnetic field. Or the magnet is there, or the conductor is there, you're moving the magnetic field. So some way or the other, one of this is changing, let's say. If this is changing, conductor is still not carrying current, but if these two are changing, then it will produce a current, it seems. That is what it is saying. It must be a bit confusing. All three sound a bit similar, but they're different. Same, but different. Okay. In this scenario, we're producing a current. Now, conductor is always not carrying it. I'm thinking about food itself, so I'm sorry about it. But like, it's not carrying a current. No, give me a second. I'm trying to find my wire. Now, if I take a wire, I see. So if I take this wire, do you think it's carrying a current? Right now, it's not carrying current. If not, if I hold this, I would have got current shock and I would have died by now, right? So it's not carrying a current here. So it's a conductor just. You bring a magnetic field close by and you change. You either change the magnetic field or change the, you move this magnetic field next to the current carrying conductor. Then not magically, physics, according to physics, a current will be produced, it seems. That is what you call as electromagnetic induction. Okay, right. So that's about that. So the whole definition of that would be generation of electromotive force. Okay, or electromotive force, another term is current. EMF here, we say EMF, electromotive force, is another term, a fancy word for current, right? Generation of electromotive force between the terminals of a conductor, right? When the conductor is kept in rest in a changing magnetic field, or when the conductor is moving in a constant magnetic field. Either the magnetic field is changing or the conductor is changing. Something is changing. So if you want the full definition, go to page number 132, see the definition, and write it on your chart, okay, later. Right? So that is, you have to know that by heart, okay? So whatever happens, even if it's your last breath, if the molecule mouth won't ask you that, but if somebody comes and asks you before you die, you should be able to tell this, okay? That's how important it is, okay? Now, the current, it depends on three factors. Now, I told you earlier also how about this current depends on. It depends on BTS, not the BTS band. This is also all of this stuff, the teaching tactics that I'm using and everything, I would give credits to my science teacher. Okay, now don't ask me who my science teacher is, I'll tell you later, right? So thanks to her. So the current, the current, it depends on three factors called as BTS. Okay, so B is basically standing for what? Can you all tell me? So you're not bored. I already told what this is. Can you all tell me the three terms? If you all can text fast, you all tell me. If you all are texting slow, don't tell me. Just tell it from your mouth and just wait. Okay. Others who can text fast, don't tell me. What is BTS stand for? You can know. No, don't tell me the band. Okay. B. What does B stand for? According or T, you all don't know. I think unless you all in the same teacher I went to. B, you all know what B is, right? Yes. Bilal, correct. Magnetic field, right? B is magnetic field, and T is turns of coil, and S is speed of the conductor. So these are the three factors. Now, if you all are going to the same teacher that I went to, it's another revision for you all, right? So don't think, oh, she's teaching the same thing the same way, something like that, and you're leaving. No, it's like another revision. So try to make use of it. Okay. I'm not going. I'm being creative from my side as well. There are a few things that I also will be doing, right? So stay till the very end and let's see what we can do together, right? So now the current, it depends on these three factors, B, T, S. B is the magnetic field and T is the turns of coil and speed of the conductor. Now what is this turns of coil? Now here we have the this thing, right? Now this one, I made a small mistake, a big mistake actually. This coil here is actually not the magnetic field, okay, my bad. This is the conductor. Okay, have you all seen solenoids? I don't know if you all know solenoids. I don't have a solenoid with me at the moment. It's like that like this, a spring you call it. So that spring is a conductor, right? If you think about it, it's a conductor. Okay. And inside the spring, we'll say you send a magnet. Okay. Inside this conductor, you send a magnet, right? You send it in, you send it out, you send it in, you send it out. When you do that, you get a current. Okay. So the thing that I drew like this is actually a conductor, while this thing is the magnetic field. I mean, you can do it the other way also. It's not wrong. What I said earlier wasn't wrong, but I'm just trying to be precise here, right? So the magnet, this is a magnet, a bar magnet that you're sending through a solenoid or a conductor or a spring, you call it. If you send it like in and out, in and out, in and out, you can get a current. Okay. And this current depends on the three factors. Magnetic field, how strong the magnetic field is. Let's say you have a very brand new magnet that is going to have a higher magnetic field, right? The second one is the turns of the coils. What coil? This coil, the solenoid or whatever the conductor. Now, if you don't know what solenoid is, you can always Google solenoid or any conductor that you have twisted like this thing, okay, like this. Okay, a spring, you can call it anything. So how many turns of coil is there? It matters. The higher the number of coil turns, the higher the current you can produce. And the speed of the conductor, how fast you move the conductor in and out. The faster you move it, the higher the current that you can get from this. Okay, so that's simply it. And for this, when you do this, the current that is produced will be an AC current. What is an AC current? The alternating current, right? An alternating current will be produced, not a direct current, an alternating current. Okay, so in detail about alternating current, it comes under where? Under electronics. Okay, sometimes I might talk too fast. You can tell me. I will slow down, right? If it's awesome, because last time someone told me that I'm speaking like in the Zoom, you have the 2x speed, no, 2x or 1.5x speed. I talk like that, it seems. I mean, I can't do anything about it, but I will work on it, right? If I'm fast, you can tell me, no worries, okay? Right. So the other thing is, yeah, so that's it about that. Now you all have, what is the point of this? Now we're going to find a current. What do we do to find this, right? So in this only we use the Fleming's right hand rule. If you can't really differentiate what is left hand, what is right hand, you can do this one thing, okay? This is dumb, but don't do this, before you go to the exam. In the exam hall, if you always get confused, just write like this, right? If you're finding the force, oh, I can't. If you're finding the force, you use the left hand, right? If you're finding the current, oh, I'm not a left-hander, but I tried my best. Yeah. So if you're finding the force, use your left hand. If you find the current, use your right hand. Okay. Simple. If they ask you to find the current or the current that is induced, we go with the electromagnetic induction. Okay. Same thing, right? Same thing as this one, only we are going to use here also. Here also, same thing, just like how we did like this, we use like this. You find the current, but you use the right hand rule. Fleming's right hand rule. Okay, electromagnetic induction, finding the current, Faraday's law. Here also, I would recommend, now here, I don't have a way to remember this for you. Okay, now how to find this, I don't have a way. So what I'm going to tell you is, in your mind, you use the same thing that we used before. Same that we used before means FBI, but it's not the same thing. I am just telling so it's easy for you to remember. Okay, FBI. Okay, in your head you do like this, but in the exam if they ask what is this, what are these three fingers denoting, you don't say FBI. Okay, you don't say force, magnetic field, and current. For your ease, now you all already have a lot to study. History have, single have, maths have, that have, this have. So you all don't have time to remember the statistics, right? So FBI here also remember FBI. Okay, FBI in your head. But the truth is this. Here the current is not just current. The I here doesn't just stand for current. It is the induced current. What is induced current? The current that is produced. Okay, the current that is produced is only denoted by this I. Understood? Right? So this B here is of course same thing, magnetic field. Okay, the F here is actually the direction, the basically it's a motion. The F here is force, no. So force you can equal it to motion, the direction that the conducting wire moves here. We can say it's a motion, right? So F is that basically the motion. Now if they ask for the exam, what is this? You can just say the direction the conductor moves. But in your mind, you understand, no, if you say FBI, F means force means motion, B means magnetic field, and I means the induced current pillar, you can say in your head. But this one, you have to understand that it's not a force, it's the direction that the conductor moves. Okay. So now I stressed on that enough, but for questions, it won't affect much. Okay, because FBI, it's gonna be like the same thing for you. Right? So now let's see, okay. So this is a magnetic field, and then our current, I can't really say. So I just put like, what can I do? Okay, I'll just do like this, okay. Okay, I'll just put like this. I'll only find for this side, okay, for this side, coming out, sorry, going in, no? I'll just coming out. Let's see coming out, okay. Magnetic field, FBI, okay. B and then I, current is coming out. That means the force is going to be this way, right? Oh my god, my hand is, I'm gonna paralyze now. Something like this. Okay, so it's gonna go downwards. Okay, so the current, the induced current is downwards. Sometimes it's very hard to find out, just like how it was hard for me to find. If it's hard for you to like flip your paper, you know, now you can't flip my board, no, you can flip your paper to the direction you want and then try to keep your hands fixed and fine. Because sometimes your hand can go like this, that is really hard. Okay. I can agree with that. I can totally relate to that as well. So like try to flip the page the way you want it and try to find the induced current, right? So that's how you do it here. So this is just a very short example, right? So we do questions from that as well, right? I can't really guarantee we do a lot of questions because we have studied hydrostatic also. So now it is used. Can you tell me some uses of this if you have studied? Now some of your December students, you all are new to this, so try to understand the basic. Okay, when your teacher teaches you, you'll understand further. Okay, because in these 3 hours, I can't really go in depth. I hope you understand that. So can you tell me some uses of electromagnetic induction? Yes, very good, Tejani. It's dynamo, microphone. Who else? Yes, Bilal, correct. Yeah, you are too extreme. Okay. I don't know if that's so no, they said it was a compliment, but I don't know if you're sounding it as an insult because in Zoom, Dadabada should watch, no? You know, if I'm fast, tell me, okay? Yes, Ibrahim, correct. Transformer. Okay, so y'all are giving the answers. Very good. Okay, so y'all are like still engaged. I'm really happy. It's making me energetic. Right. So some the examples you can take is AC current, dynamo. Okay. Some examples you can say AC current, dynamo, transformer, like I said. Okay, transformer. Okay, I'll not write it. No, microphone. You know, the moving coil microphone and what else? The bicycle dynamo and all of that. Right. So the energy transmission here would be now you're not moving something. No, we are moving the now there's a solenoid or something. You're moving the magnetic field in and out. Right. So when you're doing that, so there's a movement and then an electric current is produced. So the transformation would be mechanical energy to electric energy. What is the mechanical energy? Like kinetic energy. You know, kinetic energy is the moving energy. You know, so when you're moving it, okay, the mechanical energy is transformed into electric energy. Okay, so that's the energy transformation. So since y'all are begging me for break, I mean, we have a lot more to do actually. I'm wondering if we can complete hydrostatic also. Let's see, okay? Anyways, y'all sleep at 12, right? Let's do it at 12. Okay, okay, just kidding. Already only 37 are there. All of y'all are. Okay, how are you speaking so much? My mouth is hurting. Why is your mouth hurting? I mean, you feel like your mouth is hurting. My mouth is already hurting. I can feel my throat is gone also. Okay, so you can take a break now. I'll give you all a 15-minute break. Okay, 15 is too much. No, 10-minute break. In this 10-minute break, go do anything you want, right? Pray, eat, drink, but not drink. Drink water. pray, do anything and come back. We will continue the electromagnetism lesson and go to hydrostatic pressure. As to the tune, the answers, now some of the questions I won't be able to do, that's the truth, right? I'll send the answers and I will clarify your doubts personally, okay? So we will do as many questions possible though, because most of you have requested me to do questions, right? So I will do it. Don't worry, I'll keep your word. Let's see. Go and take a break and come until 9:15. Okay? And if you have any doubts, you can stay back and ask the doubts. I will clarify now because most of you had asked me doubts. 48. Oh my god. How am I going to read all of it? What that dot and cross indicate? Are you still there, Dakshalan, right? I don't know your full name. If you're still there, can you reply to me? I can explain it now. What is the energy conversion coming under magnetic force part? The energy conversion coming under the magnetic force part would be electric now because think logically, right? So the electric energy is being converted to mechanical energy. So if you think logically, we are creating a force, right? Force is what is moving, right? So the force is a moving energy means moving energy is what kinetic energy, no? So another word for kinetic potential energy is mechanical energy. So this is this thing for the magnetic force. So if I missed your doubts, you can check it from there. Yeah, after break, don't go missing, okay? If you're going. After that, I have to teach the ghost only. If you teach us to do questions, because even after I understand the concept, it's hard for me to apply in questions. Yes, noted, right? I will tell you how to do that. Okay, don't worry about it. How to apply. Yeah, we just start the questions now. Once I do the questions, it will get clarified, right? So now physics is true. It's not just about understand the concept, but some of you don't know this concept. That's why I started teaching. We will do questions with it, okay? Don't worry. Most of you have asked me questions and you all have left. Now I don't know I don't know whom to reply the doubts to. Okay. I think I replied to all your doubts. If you have any other questions, please ask me. If you all have like lengthy doubts, like about the session or about anything, that I can personally reply to you, better if you send it to me on WhatsApp. Okay. Shuraim, you have asked me a doubt, right? About the voltage and the current graph. I'll clarify to you. Right? So until others join, I'll just clarify that point to you, right? Today for the exam. Oh, right. So, oh, okay. So you all have exam. No wonder the crowd is low today. But isn't today Sunday? How is that possible? Okay, anyways. Okay. So the graph goes like this, Shuraim. So the y-axis would be the voltage, and the x-axis is current. Make sure you put the unit. Make sure you put this 0, 0, right? And it goes like this. So you might wonder how this graph comes. Now, anyways, I was to teach this. Okay, since you asked me, it's good. Oops. Right. So, anyways, I was to teach this. So, like, I don't know if you're there here, but it says you're there. So I hope you're not like eating and waiting. But yeah. So how we find it is actually like this. Now, what is it? V is equal to IR, right? So Y is equal to MX. Okay, so basically in mathematics, you know, say for physics, there is always a reason, okay? Sometimes you might feel like one point is here, one point is there, you don't know what is the connection. There is a connection. Some of the connection is not there in your level of understanding. That's the issue, right? So V is the y-axis and I is the x-axis. So what is the gradient? The gradient is M, no? So in mathematics, you know this, right? So the gradient is the resistance. So this is the graph. If Shuraim is there here, this is the graph, and this is what you asked me. It's actually there in your book. Let me check the page. Page 152 of the grade 10 second book. Pretty direct question. Don't interchange the axis. That's the whole point. Okay. Miss, I didn't hear this part. Is frictional force and applied force equal? Not always. Sometimes the object doesn't move when the frictional force is high, right? So in the, now if you see, now this is also graph related to what you asked in the question. Who is this? Safia, right? Now the question you're asking is actually like this. Okay, now you're asking me about the graph of the friction, right? So here in static friction, of course, the friction and the applied force is same, right? In static friction is always the same. That's why it's not moving, right? The applied force and the frictional force is the same. But in limiting friction, right? So this is the friction force, the axis, and this is the applied force. I didn't write the word force, okay, because it's time consuming for me. So in static friction, it is equal, but here the friction is higher, right, than the applied force. Sorry, the applied force is higher than the friction, right? So, but somehow I can't even, I haven't put values now. So the reason it starts moving is because our applied force somehow dominates the frictional force. If not, because of the friction, you can't push, right? And that's how the friction becomes lower and the applied force becomes higher. So that's why it starts to get pushed. Now you can understand it logically, but if you really, your brain cells are not ready to understand it, then I would prefer you just memorize this graph and say, okay, this is static, this is limiting, this is dynamic. What else to do? Because now it's not the time to sit and understand. No, a few days left, right? That's the hard truth. But you still can change, okay? The change your ways because there's still time. I wouldn't say there is no time. Even from a level of S, if you have the will, you can not only get an A, you can get 9s, hopefully. If I'm not being delusional. Okay, I'll start then. Okay. Oh my god, I took 6 minutes and I don't know. I think most of you are not here. I don't know if you're on Zoom. I don't know. Sorry, if you're on YouTube. So let me continue, right? Okay. So now let's go and do a bit of questions, no? Because I feel like doing this itself, teaching theory itself. Now you all know. Some of you all know the theory also, no? So let's just go and do like a few questions from the MCQ, and let's come back to this. How does that sound? How what do you all think about it? Are you all there? Just to check if you are there. What do you all think about it? Yes or no? Shall we do questions first and come back? Because there's a bit more in electromagnetism. There is also hydrostatic. So what do you think about the idea? I need your opinions. That would be great. I don't know where. Okay. So you all are here, no? Nicely 8 and came. That's amazing. Okay. Questions. Okay. So all of you love questions. So let's go for questions. Right. So when I talk about questions, I will not be how do I explain? Like it's like I will not be teaching the theory, but I will give you the background. Okay. Like background of it, like how to answer the question and stuff. Because some of you all had asked, how can I approach questions? Because that's a good question, right? The asking the question on how to answer the question is a good question. Okay, so that's a tongue twister. Okay, so now go to page number 20. This is your favorite. Okay, electronics, most of your favorite questions. So try to answer the question. Tell me the answer. I will tell you all a tip to remember. Okay, so it's like I can't really teach the lesson of it, but I'll give you an overall background. Now, when it comes to answering questions in physics, especially not only physics, even history, other subjects, this applies, right? So usually you have an answer, right? You have a question and you have four options, usually, right? And in this four option, rather than you now you're not okay. Sometimes you're very confident, you know this is the answer. Okay, most of the time, majority of the time, you know that either this or this is the answer. So how can you really figure out what is the answer? So how you figure it out is by elimination technique. So elimination is like this, okay? I will teach this properly in the guidance thing and all, right? So elimination is now you know definitely, right? Sometimes you have a question, you know this answer is pachapoi, okay? You know this answer is definitely not the answer. So you eliminate that, okay? It's I don't know. It's like a the you know that even a 5-year-old will know that this is not the answer. So that answer you in your head you eliminate. If you feel like in your head your head is bearing too much already and you can't keep it in your head, you take a pencil and you cross it. And then the third question also feels like you're not sure about this. Second question you feel like maybe it's the answer, but fourth question also again it's a lie. So from the second and third, there's a 50% chance that your answer will be correct, which is the second and third, right? So then you try, you think about it. Now I will tell you a way how to answer the question on the guidance. Okay, so I will tell a proper way how you can answer the question and secure the marks. For now, I'll just tell you the way to answer in physics. In physics, it's all about solving. No, so if you at once can find out these answers are wrong and these two require a solving to do, then you solve these two and see what is the answer. And then if there's the answer, you choose that. Okay, so that's like common sense, but I will properly tell you on the day of guidance, right? So now tell me the answer for 17th question, please. The NPN transistor. Let's see how many of you all know electrons. Because this is the chapter most of you all find difficult. It's not difficult, right? I'll tell you a way to remember this. Yes, very good, Tejani. Others. Let's see. Ibrahim has sent me an answer. When is the class over? Are they? You've had time. You want the class to be over. You tell me. Let's see after that. What, you all have something after this, no, right? Okay, tell me the answer for that. Yes, two questions, okay? Some people have said let's do questions and they have left, maybe they're doing on their own. Yes. So NPN transistor, I'll tell you a method. Okay, this is something my A-level teacher taught me. Okay, it's in Sinhala, but I'll tell it to you in English. Yes, was correct. Your answer is correct. I'm sorry, I didn't, I didn't reply to that. Yeah, I'm sorry if I don't reply to your answer. Sometimes it's correct. Okay, Hamida also correct. Right. Anyways, now NPN transistor, I'll tell you a way to remember it. Okay. So NPN transistor, remember this is funny. Okay. His name, a person called Nipun. Okay. Nipun's arrow is out. Now don't wonder too much, right? Just remember Nipun's arrow is out. In Sinhala, you say Nipun ge itala elia. Okay. So remember Nipun's arrow is out. Remember that. Okay. Don't think about P and P. This is only about NPN. Okay. So how do we actually connect this to this now? So now how does an NPN transistor look like? It looks like this. Now I'm not going to teach you what is a transistor and all of that in detail. Okay, I'm just telling you how now that concepts like this, you have to find easier way to remember. Even in bio, it's like that. Okay. Right now, all that matters is you put in your short term and remember until the exam, then after exam, forget it. That's the truth. Okay. So Nipun's arrow is out. So now this is the transistor. Now Nipun's arrow is out means arrow is out. It's going out. This is the transistor. Okay, now I circle. Oops. The arrow is out. Okay, right? So most of you know singular, right? Anyways, so this is N, P, N. Okay, P and P means opposite. P, N, P. What is N? What is P? N means negative, P is positive. Okay, that's all I can teach for now. In detail, if I were to explain, it's like I have to go into forward biasing, reverse biasing, all of that stuff. I will not teach too much about it. So this is NPN. Now we'll stick to the question, right? So this is how an NPN transistor looks like. Okay. And you know in a transistor that this is a collector. Okay. This is a collector. Now in the question, in second question, in the 18th question, you can see C means collector, E is emitter, and the P is base. So in my concept or in my mnemonic, I said Nipun's arrow is out. That means it is this. If it's like this, then it is an NPN transistor. If it is going inside, then it is a PNP transistor. That's the way to remember because we get confused, right? What is NPN? What is PNP? Now it's not confusing at all because arrow out means it's NPN. Now you can solve your question very easily. You have drawn this. Go to the option base P, correct. Emitter N, correct. Collector N, correct. So what's the answer? Answer is number 1. Okay, that's how we solve that question. So 17th question we did. What about 18th question? 18th question I already do and I told you. Can you tell me the answer for that then? Can you tell me the answer, please? You are responsive and I love it. It's very nice that you are being responsive and yeah, correct. Ibrahim, your answer is correct. And Ibrahim, you tell me a class time to finish now. You asked me what time I'm finishing. What time do you want me to finish? Yes, Hamida, correct. What about the others? Hamida sent me the answer. Did you all try the others? Yeah, Tejani, 18th question. 18th question, page number 20. Page 20, 18th question, right? So now the people who are leaving, you're going to miss out on the most fun thing. Sorry to break it to you, which is the circuit and all of that. Let's have some fun, okay? And go and tell them, okay, after the class finishes, see, I did this. I mean, you already knew you all were watching, but still. Okay, inshallah, you decide. I'm fine. That's how you should be, Ibrahim. Very good. I will decide, okay? What? Let's see. Because as I want to teach you as much as possible because it's gonna help you a lot. No, if I'm boring, you'll tell me, okay? I will try to figure out what to do. Muaz, check your answer, please. Your answer is close, but it's not the answer. Somewhere close, but you went close and you went far away. I don't know if people are leaving because I'm ignoring some of your DMs. Miss drag till the next day. It's very interactive. Will you lend me your throat? If you can give me a voice in your throat, I will be ready to do it. Now it's so I can feel like my throat is gone. Yes, Shimra, correct. Shimra, correct. I'm waiting to hear all send the answer, right? How I didn't understand the question. Okay, you didn't understand this question? So it's like this, okay? Obviously, you're not going to understand if I tell you at once. Now, transistors, there are two types, okay? NPN transistor, PNP transistor. Now, I'm just telling you a fact. Remember it this way. Okay, there is this saying called, if you all know Sinhala, you all will know this. Okay, I mean, you all will understand this because I don't know if you're doing Tamil or like in English itself. Okay, Nipun's arrow is out. Okay, so this person called Nipun, why I took Nipun is NPN. I didn't take my cert, okay. So this NPN transistor, the arrow is out. Okay, if it is PNP, it's going to be the opposite. Okay, what is transistor and all? I can't teach now. That's the issue. That's the whole problem. Maybe that's why you have a doubt, right? So always this collector emitter base, it will not change. It's going to be the same. So here also this is the collector, this is the emitter, this is the base. Okay. So the question they are asking the option regarding the NPN transistor. So they are asking in the base, what is their P, right? In the collector, you just have to draw and figure out. In the collector, it's N. In the emitter, it is N. If they ask about a PNP transistor, remember it's the opposite of Nippon, which means the arrow is going inside. Okay, if the arrow is going inside, then that means again this also will change. Okay, that means PNP, not PNP. PNP, right? So that means it will come like base is having N, collector P, emitter is P. Okay, right. So most of you have sent the answer. So I'll go into the question, right? I have no time to waste also. Let's go into the question, right? Okay, so in this also the same scenario. So they have given you also, they are spoon feeding it to you. That's how the exam is. Okay, they will give you the answer in your fingertips. You have to figure it out using your brain cells. Okay, So this is base, this is C, this is E. What is E? Emitter, right? In the question they have given E, that is denoting the emitter. C means collector and D means base. Okay. And here they have given the arrow also. What do you have to what really do you have to find then? Everything is given, right? So I said Nipun's arrow is out. So if someone's arrow is out, it's Nipun, right? So N, P, and N. Okay, NPN. Okay, so it is an NPN transistor. Of course, it has to be now here the same thing, right? Now the same scenario I told you earlier is happening here. First question, second question, NPN transistor. Now someone made this mistake. I think it was Moaz, right? Someone made this mistake by saying the answer is two, right? So first and second, you can say first NPN is correct. PNP, 3 and 4 wrong. Of course, it's not PNP, it's NPN, right? How is the current flowing now? Now the first part is correct. Second part, now this part you don't even have to think about because first part is a wrong, no, so forget it. 1 and 2, let's go to the rest of the question, right? I mean options. Current flows from collector to emitter or emitter to collector. How is the current flowing? You see the arrow, right? Follow the arrow. Current will come like this, and then it will go with the base current. Both now the current is usually now if the arrow is this way, the current is coming like this. Now this current also will come with it. So this will all join together and it will go like this. So how is the current practically coming? From a collector to emitter. According to the arrow, basically. This arrow itself, you try to go back. See, collector to emitter is the answer. So the answer is answer number 1. I hope you understood that. Yes. Yes, it's the first one. Very good. Nice. Okay. Now that's how you do that's how you figure out questions in physics. It's not hard. You just get overwhelmed when looking at the question if you have never seen it before, right? Okay, so let's go to the next question. Right. So now we're going to DC motor, right? So let's go into DC motor and let's come back to questions. Let's do like that. Then we can cover it up hopefully. Now I have to teach you about DC motor, right? So now you all know, some of you all know all of this. If you all know this, try to recall, right? Recall, because recalling is very important, right? So recall this with me. Right? So now we have the South Pole, right? Here also I'll try to finish by 10:30, no worries, right? I'll try to finish. Let's see if it's practical. I'll finish by 10:30. Okay, so until then, hold on tight, right? Maybe after 10:30, I'll be able to do that circuit thing. If you want, you'll stay. If not, it's fine. You can leave. Okay, the circuit and the magnet and stuff. Okay. So this is, I can't draw it 3D, but if you take your book, you can check it out, right? So this is a North Pole and this is a South Pole, right? Magnets. Now this is I'm talking about, I'm going back to electromagnetism, okay, and we're going to talk about the magnetic force. So this is the part that is most confusing for you all. Okay, magnetic force, if I'm speaking about the DC motor especially, you all are confused. Now, what is this DC motor? How is it connected? What is it? You have a doubt, right? So this magnetic force, this is how DC motor looks like. You have two magnets. This is the South Pole, let's say. This is the North Pole, let's say. Okay. And we have something called, this is the part of the DC motor. Like if you take, I'll show a video on this, okay? Once I'm done teaching this, I will show you a video, then it will make more sense to you. Now this is the top, I'm drawing the top view, okay? I can't draw the side view or any view. I mean, I have artistic skills, but it doesn't apply for physics for me, so I can't really manage to draw a 3D, okay? So I hope you understand that. I'll show you a video though, once I'm done teaching, okay? If you all haven't understood. So this is called as the armature, right? This is called as the armature, okay? And this is the North Pole, this is South Pole. You know what North Pole, South Pole are. They are the magnets, okay? And then we have this thing called, this whole setup is called as a commutator. This, it involves, it has something called the brush here, and it has something called a split rings. Why it's called a split ring is because it's like a ring that is being split into two. So can you see here? It's like this. If I zoom in, so I'll zoom in, like if I separate it, it's like a ring that is cut into two. Okay, it's not symmetrical. Okay, it's cut into two. Okay, that is what you call a split ring because it's being split into two. Okay, and there is brushes. This thing here and this thing here are the brushes that's holding onto the armature. So armature, they are using this fancy term just to scare you. Okay, now this armature is actually current carrying conductor. It's a conductor. It's a conducting wire basically, right? This is a split ring, and this is a brushes that is connected to the armature. Okay, and then this split ring is connected to a circuit. There's a dry cell here. Okay, circuit, that's it. Now, how is this applicable to our magnetic force concept? That is a question that you will have, right? So if I were to tell you, now there is a current here, right? This current is flowing through this armature. So this is how the current will flow. How will the current flow from positive to negative? No, positive to negative, right? It will flow like this, positive to negative. This is how the current is going to flow. If I were to show you positive to negative, current is flowing. Okay, so therefore it will flow in the direction of, if I were to label it, I'll just label it as randomly A, B, C, D. So it's flowing from A, B, C, D. That's how it's flowing. Okay. So the magnetic field, it travels. Now, what about the magnetic field? Can you tell me from small days, they have been telling you from which end to which end? Is it south to north or north to south magnetic field? Soon type and tell me. Don't sleep, okay? I know you'll sleep at 12, 1, 2. Yes, your sir has showed a video already, okay? It's okay. I'll also show, okay? I'll show you full screen, like how I speak. What is the device that is used to convert AC to DC? Is it DC to AC or AC to DC? And smooth that current. Smoothing the current is done by capacitor. And I have a capacitor to show you, by the way. I kept it. Yeah, this is a capacitor. I had it with me. So to smooth the current, you use the capacitor. So this is the capacitor. This is how it looks like. Okay. I was waiting to show you. Good that you asked the question. So tell me the answer. Tejani has sent. Sorry. Yes, north to south. Right. So it's north to south like this. Okay. So magnetic field, north to south. So it's going like this. I'm denoting it in green. Okay. So it's going from north to south. Right. So now we can use our what? Now since it's about the magnetic force, we're going to find the force now. To find the force, do we use left hand or right hand? I literally wrote on my hand. Oh, now it's gone. Can you tell me which hand do I use to find the force? Now current is there, magnetic field is there. What do I use to find the force? Yes, very good, Tejani. Others was using fans, no. Yeah, we use the capacitor in fans. Actually, there was a broken fan at home. I took it. Right hander, bro. What? No, it's a right hand. If I miss your doubts, please send on WhatsApp, okay? Yay, okay. It was easy. Okay, this I did not think it was gonna be that easy. Yes. Yes, very good, Bilal. Okay. I don't know how many others sent me the response, but I'm hoping you have sent, okay? So now, left hand, we use the left hand, right? Someone said right hand. Right hand is used to find the current. Right hand is used for the electromagnetic induction. So like if you want, you can write it in your hand and keep this side force, this side current. Keep it in your hands when you're going to sleep, see and sleep. Okay, I'm just joking, but try to keep like try to understand. Okay, so left hand is for the we used to find the force. Now I'm finding the force, right? So now the magnetic field is there, current is there. Now I'm finding the force. So we use the left hand, we use the yo-yo sign. Okay, not yo-yo, but like perpendicular sign. Okay, FBI. Now, what I wrote, FBI is also gone. You can write it and see. FBI. Okay, don't change this. Now, FBI. So it's going this way and then it's going this way, right? It's like this, no? I can't. Like this, no? FBI. So it's like this. That means how is the force? Force is coming out or in? FBI. Correct? No? Yes. How is the current, sorry, the force going? Can you tell me? Out of the page or into the page? Someone didn't understand out of the page or into the page back then. Did you understand now? Can you tell me? Is it out or in? I'm teaching from basic, okay? So that you can catch this. Out or in? Do and see from your own. Why do we use a resistor or a rheostat? What? Resistor or rheostat is to find the resistance. It's not related to this. Yes, it is out. Ibrahim, very good. It's out. Okay. It's coming out. Okay. So you put a dot. Okay, I won't put a dot. Okay, just to make it easy for you all, I put like up. Either. And then I'm going to find this side now. This side only I found. I found only this side. Forget all of this. I only found this side. It's like a normal question, a basic question where I'm only finding. Now, earlier we didn't know from north to south. Like this means current is going like this. It seems. So I used only for this side and I found FBI here. I did that and I found. Okay, so it's coming upwards. Okay, that means outwards. That means dot. So I put dot, instead of putting dot, I put upwards. Imagine it's coming 3D, okay? Something like this. Okay. Now I'm going to find for this. Okay, for this if I'm finding, is going to go downwards and then it's going to go like this. Okay, so if I'm separately doing, this is the current and this is the magnetic field. Can you tell me now? Can you do alone and tell me what is the direction it's supposed to go? Yes, yes, I was going to tell you that also. Okay, I'll tell that. First, once tell me the answer, I'll tell you what Ibrahim has told me. Tell me the answer to this soon, soon, soon. Is it hard to text? Yes. Yes, very good. Okay, it's into the page, right? So if I were to show you FBI, B, right? FBI, okay, B and this way. So in, okay. I can't really, it's like, it's hard for me, but if you all try it and see, you can do it, okay? So it's going into the page. You have to turn the page and you have to do that. So it's no worries, right? So now can you see it's going opposite motion, right? So it's like basically this is going inside and this is coming outside. So it's going in opposite motion. What do you all remember when when I say this, it's going the forces, it is going down and that's going up. What is this called as? You'll have studied in grade 10. What is this called as? One line of action, two forces. What is the term that you use? What is the term? Rotation, yes, rotation, but there is a specific term you are studying this. Very good, Bilal. Couple of force. There is one line of action, there are two forces. So there is couple of force, so it will rotate the armature. Okay. So that way, when it's pulling, if you have studied this in grade 10, so when you're pulling the two forces in opposite direction in one line of action, there is going to be a couple of force. Same scenario when you're opening a tap, when you're driving a steering wheel. One line of action, two forces, right? So that is the couple of force that is acting here. So simply because of this couple of force, there is going to be a movement. So this is the DC motor, and someone, I think, I can't remember who told it now. The reason, can you all tell me the reason why we are not taking the forces from here and here? Can you all give me an idea? Do you all have an answer? Do you all have an answer as to why where I'm not applying Fleming's left hand rule from here? FBI, why can't I apply this current and this force and check? Why do you think that I can't use this current and this magnetic field to find the force? Anybody? Let's see who's smart here. Yes, Amna has told the answer. I'm sorry, I just saw it. Yes, Ibrahim has told me the answer. Anybody else? Do you all know the answer? Yes, very good. Very good, Tejani. So it is because it is parallel. Right? It's not perpendicular. Now I told you FBI is used by if it is perpendicular. Now can you just think, can you use this FBI? Now here let's say I. What about this? I have to like break my finger and like do something and do it. So it's not practical, right? So this current and this magnetic field, they are both parallel, right? So since it's parallel, it doesn't make sense to use FBI or the Fleming's left hand rule for this and this part. So that is we avoid it completely. It's going to be zero, right? So that's why we only use these two forces, and there's going to be a couple of forces which will give rise to a rotation. And yes, it is a clockwise motion. Okay, because if I draw it like this, it's going to be a clockwise motion. Okay, yes, that's it, right? So that's it about DC motor, nothing complicated. So that's all, right? It will give rise to rotation. And why we use, you have to know the function of an armature, right? Armature is used, without an armature, we could just go with like one this thing. No, why do we use an armature? We use armature so that it can rotate. Now there's two forces that are created from both the sides in an armature. That's why we use an armature, so it can properly rotate. Okay, when a current is passing through. Magnetic poles are there to bring a magnetic field. And a commutator, I'll explain. This one you'll understand the video. Okay, the commutator, oh my god, my drawing is so bad. I hope you all are not going crazy looking at my drawing. Okay, this is a commutator. No, this commutator is used to alternate the direction of current flow, an AC current. Okay, alternates. So that means something it will like flip it. I'll show it in the video now. You all can watch it and understand it further, right? Let me show it to you. Watch the video. It's perfectly understandable. Okay. Hold on, give me a second. Don't go missing. Okay, wait. Okay, forgot to share the sound. Okay, okay. Now you can watch it. I'll put it in a bit speed. Okay, it's just okay. You can see, right? So these are the two magnets. Okay. So it doesn't have to make full sense to you because in A levels only you all are learning in depth. Okay. So now if you just understand this like this, it's enough. So this is the armature. Just watch it carefully, okay? If there's something that doesn't make sense, don't worry. So these are the split rings and the brushes and the wires. And you see the current is flowing like that. Okay, you see there's so many right now in your syllabus. We have only talked about one armature. So there are so many armatures actually. See, this is how a DC motor actually works. So it's not in your frame of knowledge. That's why sometimes you can understand some things, right? That's how a motor works. See how fast it works. Okay, that's it. No. Okay, right. Okay, that's it. Yeah, so like this, if you can understand concepts, I recommend always watch some videos, try to understand, try to self-study along, right? Try to understand it yourself because sometimes you can't just blame the teacher and move on in life and say the teacher didn't teach me. You can do that. But now in this day and age, you have the resources at your fingertips, right? So use them wisely and, study it yourself. Okay. So that's about the DC motor, right? It's not complicated now. So actually now we can go to a question, the essay, right? We are all set to go to a question. Go to page number 22. The last part we don't have to do it. Okay, so page number 22. I'm going to skip. I'll give the answers to it though. Just do page number 22, question 3. Now, I'm not going to give time. We just because I already told her to do and come. But you don't need time also. Just do 1, 2, 3. That's it. Okay, if you have done, send me the answers in the chats. Okay, I'll just give 1 minute because we have to go to hydrostatics. Oh my god, there's only like another 30 minutes left. I'm gonna fly like a jet now. Okay, so if you have written the answers, if you have already done it, send me the answers soon. Yes, brushes prevent external circuit from rotating. Yes. So there are other uses as well that I didn't mention. Seems like Ibrahim knows a lot about the electromagnetism. So if you have any doubts, ask me. Moaz, I'm very bad at science. No, don't worry. That's your mindset, okay? Science. Even I thought I was bad, but didn't I get an A? Even I thought I didn't like science, but didn't I choose A-level science? So it's like that. You will think you're bad. Don't underestimate yourself or put yourself down. Study. Even now, it's not late, right? Science, if you understand the logical aspect of it, it's easy to move on, right? Like you can watch videos. There's so many ways that you can figure it out. If you want help, personally ask me, okay? I'll try to give you the help that you need. Class finishing time 10:30. But after 10:30 only, I'll be doing the magnet thing, okay? Magnet and the current thing. If you want, you wait and watch. If not, you can go. But don't go now, okay? I'm not done yet. Okay, so let me start with the questions, right? So now in this in the tude, right, you have this question number 22, question number 3. So I will not draw it again. Let me show you the give me a second. I don't know if it's much, it's not if it's clear to you. This one, right? So actually this what this graph and all, it's not of use in this question. Okay, it's actually a lengthy question that I shortened it into. So if you see here, they're asking the direction that the coil can move, right? And the best part is they have actually given you the direction. You know, that's how the O-level paper is. Can you see? In circle, they are given you the direction. But actually, if you see, I don't think it's very clear, right? This is not. Okay, let me draw it then. I'll draw it in a bigger way. Then you can see, no. So it's like this. Again, I have to draw now. This is the north and this is the south. Okay. They're asking the direction that the coil will move. Okay. So the direction that the coil will move, you don't have to actually, now they have told the armature, this is the positive, this is the negative. From the previous, so the top part, they have told you that, right? So if it is moving like this, has to be like this, no? Let me see. Okay, you asked, okay, not to leave to just move. Okay. I'll anyways finish at 10:30, hopefully by 10:40, right? Yeah. Okay, so this is how it is, right? FBI, So if it's like this, it's in. So the top part of the question, there from there only you find the plus and the minus, right? So here we have in the question, they have complicated a bit for you, right? So if you see the top part, they have put something like this, no, that's how they will make it. Now, sometimes the question looks easy, but they make it hard for you. So this part, plus and minus, they have put here like this, no? So you have to understand that, the plus and minus, you have to convert that to this, right? Now here you can't properly see it. That's the issue, right? Or if not, don't take it very seriously in your head. You itself indicate below. Maybe the question, there's a small defect in the question as well. So in the question, it's that you denote the plus and minus, then finish. No? The dry cell here, you indicate the plus and the minus. Then what will the rotation that will come? Is it clockwise or anti-clockwise? Tell me. What is it? Clockwise or anti-clockwise? Now I have told you how to find it. We're doing this question now. You all wanted questions, no? So we're doing the questions. Let's continue the questions itself. Clockwise or anti-clockwise? How do you think it's moving? Are you sure it's clockwise? Check your answer again. Because I don't think it's clockwise. No, it's not clockwise. Obviously, it is not clockwise. What's the answer? It's anti-clockwise. No. So it's like this, right? Very good. The ones who said anti-clockwise, good job, right? So FBI, right? B goes like this, okay? And I, this is the current, no? Flip it. So it's going where? It's going inside, right? So this is going into the page. So into the page means, what is it? It's a cross. I have told you how to find into and out, right? So if you take a marker, where is my marker? Oh my God, it's gone. Oh, yeah. This is into the page. So it's a cross, right? So FBI, I like this, and I like this, and B like that. It's going out the page, right? So this is the part. Now y'all can find this and this. Y'all can do that perfectly, but y'all can understand is it into or out of the page. That's the issue y'all have, right? So here it's coming out, and then it's going in. No, it's going this way, right? So like this. So how is it? Is it clockwise? Is it in the direction of the clock? No, right? It's anti-clockwise. Clock means it goes like this. No, clock means like this. Okay. Anti-clockwise means opposite direction. Okay. I hope you understood. So that's the answer for that is anti-clockwise. So what is the rule that we use here? Fleming's left hand rule. Why? Because we found the forces. Finding the forces, Fleming's left hand rule. Finding the current means Fleming's right hand rule. What is A, B, C, D? A, I'm just the answer because it will take some time for you to send. No, so check your answers, right? So A means armature. Okay. A is the armature and B is the magnetic poles, right? B is the magnetic poles and C is the split ring. Okay. C is a split ring, or you can say commutator, but if you want to be specific, it's the split ring, right? And D is the brushes. Okay, D is the brushes. So that's the answer for that question, right? And then let's go into the best part of this. Okay, this is the easiest part, right? And about the bicycle dynamo, that part, it's nothing much. Okay, so about the bicycle dynamo, if you have a confusion about bicycle dynamo, you can text me personally. I'll explain to a voice note. Since I'm like kind of running out of time, I have to teach hydrostatic also. I'm going to skip that part. Okay, is it okay with y'all? Because you all also want me to finish at 10:30, right? So I don't want to drag it. So I'll skip that part. Okay. So let's go jump into Transformers. Not the movie Transformer, but like the Transformer. Let me know if you're okay with the plan. I'm waiting for a response. Don't sleep, huh? Okay, right. So you're asking me to continue, so I will continue. Okay, right. So now about the bicycle dynamo, it's not very hard. That's why I'm skipping it. If not, I will not skip that. I will sit and teach you all that. That part, if you all have a confusion with that, it's very simple. The concept, the bicycle dynamo, it uses the electromagnetic induction concept. Okay, since you all want me to do questions, I'm trying to soon jump into the questions, so I'll have to teach you all the transformer part, right? So basically, transformer is another concept. Now the users, now most of you have said the users of that electromagnetic induction is transformers here. Okay, the symbol for transformer is this. This is the symbol. You all know it, right? You all would have seen it by now, right? And the current that is used is AC current, the alternating current. Okay, so now the transformer, the problem with this charts is I have to go one by one. Okay, okay. So Moaz also has agreed that let's continue, right? So now in the transformer, right, it looks like this. Okay, transformer is very simple. Okay, the word sounds like this. It's just like a metal part that is there, where you have this thing like this, the coils. Okay, this is only transformer in simple. In your level of knowledge, just know like this. There is current coming from here. There is current going out from here. Okay, this part of the transformer is called as this part. Okay, this whole circuit here, you call it as a primary circuit. Primary circuit. And this part is called as the secondary circuit. Okay, secondary circuit. Okay, so this one I will denote as IP because I primary, the current primary current, and this is IS, I secondary current. So I hope you're like taking notes. If you take notes while I'm teaching, and if that won't make you sleep, or if you feel like that is making you more focused, do it. Okay. If you feel like no, I want to focus, then focus and listen. Okay. And this is NT and this is NS. NT and NS means this one. Okay. The number of coils in the primary circuit, the number of coils in the secondary circuit. NS. Okay, so that's it. This is a transformer. Just the idea, the whole idea of this is that. Okay, and you can also give the voltage VP, VS. That's all. And from this transformer, what is the whole idea? Why am I talking about transformer? That's a good question, right? So now in this transformer, what you all have to know is just a few equations. The two equations that you have to use. The first equation would be, I'm just jumping into equation, okay? But if you want to know a lot about transformer, it used to bring current to your house. There is a transformer called step up, step down. In the chapter power and appliances, that chapter, you will learn this in detail, right? If you have learned, you know. So there is step up transformer, step down transformer, okay? You have it, right? So the equations that you are using is NP over NS equals VP over VS. This is one equation that we use mandatory. Okay. The second equation that we use, okay. So if the transformer is 100% efficient, 100% efficient means 100% useful, we will use this equation also. That means no current is wasted and all that. But in reality, current is wasted. Okay. But this is, we are studying for O level. So remember this way. VPIP is equals to VSIS. Okay, right? So this is that. So these are the two equations that you're using for any question. Just remember, if they say transformer question, only these two should come to your head, nothing else. Just forget everything else, these two only, right? That's why you'll have a problem. What equation do I apply? Where do you apply? That's the question you'll have. So let's do a question and see with this, right? But before we jump into this, right? I have to tell you that there are two kinds of transformers. What are the two kinds of transformers? Can you all tell me? Reply. Let's see if you are still awake. Some of you all must be snoring also by now. Yes, some have left, no? Yes, primary and secondary. Very good. So primary and secondary are the two kinds of. No, what? No, not primary, secondary. I'm saying the transformer types. Primary circuit, secondary circuit. Yes, I'm asking. There are two types of transformers. What are the two types of transformers? If you have studied, you know this. If you haven't studied, this is your first time learning. Okay. Yes, Ibrahim correct, Tejani correct, Bilal correct. Okay, and there's more. Yes, you all are sending the answers. Yes. Okay. So these are the two kinds of step up and step down transformers. Okay, step up and step down transformers. Okay. So step up transformer, right? What it does is step up. It's stepping up its work. If it's stepping up its work means the voltage. It just think of like a staircase. Okay, that's the way I remember. Okay, step up means you're moving one step up. Is the way I remember. I'm telling you all the way I remember. Step up. Okay, you're stepping up your job, right? Step up. Something is increasing. Okay, step up transform. Step down means something is decreasing. You're going down the stairs. Okay, oh, you can see. Okay, down. This is up. Okay, right. Step up, up. Step down, down. Right. So basically, from a smaller value, you're going to a bigger value. So step up. That means a smaller voltage to a bigger voltage. To increase the voltage, only you use a step up transformer. Right. And also in this step up transformer, the number of secondary coil will be higher. So basically the voltage will be higher in the secondary coil. In the secondary coil, the voltage is going to be higher, and also the number of coils, the number of turns also will be high. Basically, it's stepping up its work. These people are small, these people are big. It's like a step, it's like a step that you're taking up, right? Step down means from a high voltage or a high number of coils is going to a lower number. That means secondary circuit, the voltage is going to be low. The number of turns is going to be low. That's the way how I remember. Step up, step down. Okay. If you all can't understand or catch up with me, I'll tell again, right? The voltage is going to increase. The voltage is increasing in a step up. The number of coils also will increase. That means the number of coils here will be maybe 3. Okay. And here the number of coils is going to be 100,000 or something like that. That is the step up. Step down is the opposite. So many coils. Okay. And here, so many, like this is less, right? Less. Okay. So that is what is happening there. Right? So this is how what's happening is step down transformer. I hope you understood. So when your current is supplied to the houses, we make sure, remember this, okay? This is a key point. Write it somewhere in red pen or something. Please write it somewhere. When you're getting current to your house, this is an important point, right? It will go past one step up, okay? One step up transformer and two step down transformer, okay? It's not one to say. One step up transformer is used to step up your current, and two step down transformers are used to step down the current. Okay, so that's what is done there. Right, so now we can do a question from this. Do you understand the concept now? I just told this in brief, okay? So if you want, go to your book and try to figure out all of this, okay? So now go to your cute, page number 24, question number 10. Okay, page number 24, question number 10. I hope you'll have answered this question, right? Page 24, question number 10. Okay, the problem is I actually made the queue early. I already told this, right? I first put the forms and then I made the queue. Okay, that no, first I made the queue and then I sent the forms. And after I sent the form, I realized whatever I put in the queue is not what you want. You all want these chapters, right? So that's the reason I'm not able to fully do the queue with y'all. I hope y'all it's okay. I hope it's okay with y'all. I'll do the maximum, okay? I can't keep y'all until late also, no. So I'll send the answers for the questions that we couldn't do. Fill it on your own because this will help you like a short note. Now see, all of this is properly given, okay, as a short notes that you can refer. This part, all of it, it's useful, right? And this also, right? This also I hope you'll have completed. It's very easy. So you can use this to refer day before exam, right? And most of the questions I wasn't able to do now. But don't worry, I will send you the answers, but please do it, okay? And ask me questions and all of that. We will somehow complete the things that you all told was hard, okay? Right, so you all went to page number 10, right? Sorry, question number 10, page number 24. Let me go. Yeah, question number 10. So that question is very, very easy, right? So this is the question I'm talking about. I'm not able to screen share because the YouTube people can't see, you know. I don't know how many are there in YouTube, but this is the question I'm talking about. If you haven't done soon, so do it now, right? Let's jump into it, okay? So now they have told a certain transformer has 8,000 turns, it seems, in its primary coil. That means number of turns. This is how you answer the question. Okay, so always draw the picture. Okay, if you don't have a picture, always draw it. Okay, so draw of a physics, always the necessary thing is drawing a picture that you can understand. Okay, it doesn't matter if another person can't understand, you draw a picture on your own and try to figure it out. Okay, that's how you answer physics properly. I in the guidance session, right? So now just think about this way, right? So now in the NP transistor, there are 8,000 turns, it seems. In the secondary coil, NS, how many are there? There is 800 turns. Okay, so a certain voltage difference of the primary coil is 230 volts. So Baba question. Okay, they're saying the efficiency of the primary coil is 100%. That's not really related to the question. If you know it's 100% efficient, then you can use the two equations, which is NP over NS is equals to VP over VS, and which is VP IP is equals to VS IS. Okay, right. So now these are the concepts, I mean, these are the equations that we use. Okay. Now let us go into the, let's dive into the question and check the VS, right? Let's see, right? So NP over NS. Now we have to use the first equation. Now people, some of you can't figure out which equation to use. Trust me, once you draw the diagram, whatever diagram, now this is, you don't, you might feel like, sometimes you might feel like a panditya saying, I don't have to draw this diagram, I can understand it in my brain. You won't, right? Draw even the smallest diagram, make sure you draw it. When you draw it, you can understand on your own. Now, if you see this, you know that you have to find VS. And for this, what should you use? The first equation. That's how you answer the question. Okay. Draw the question, draw the diagrams always. Don't forget. NP over NS equals VP over VS. Okay. And then we go with, right? What is NP? 8,000 over, what is NS? 800. Let's see if you have sent the answer. 230 over VS. Now this is maths. After this, now this is only physics. Until here only you have physics. After that it's all maths. So you can't blame saying physics is hard if your maths is bad. Okay. Let's see how many of you found the answer. Yes, Ibrahim has sent the answer. Okay. Tejani has sent the answer. Moaz has sent, my cat is also listening to you on the table. Oh, that's nice. What? No. Who? Moaz, your first answer is correct. Second answer, innocent, yeah, but first answer is actually right. Maybe your cat did the second answer. Sorry, second question. Others, Bilal has sent correct. Okay, most of you are sending. Okay, wow, you all are active from like the start till the very end. It's nice. Okay, so like let's start the 0, 0, 0. This is 10. Okay, so I think this is where someone went wrong. Someone's cat did it and went wrong, right? So max is the problem, right? So when I cut it, make sure you cut it clearly. Okay, when you're cutting it in the exam, don't cut it using pen. You will get confused. Use pencil to cut. Okay. So when I'm cutting, I cut the 0 first. 8 and 8, so 10, Now after this, you try to figure it out. So bring the VS to this side. VS times 10 is equals to, keep the 230 on the same side. The 0, 0 cut. VS is 23 volts. So most of y'all gave the answer. Okay, that's how you do it. Okay, so probably for most of you, maths is the problem. Okay, not the physics. And then they have told to find the current, right? They have told the 10A current is passing to secondary, blah, 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 find the primary coil this. So we found no. So let's go and find the VP. Now you know what should you use? The second equation, right? VP IP is equals to VS IS. VP, what is VP? We already told earlier, it was 230, right? And IP only we have to find. VS is what? We found here. VS we found here, 23. So imagine, okay, now someone told it was 2,300. Now imagine you put the answer here, Sapatamai, finish. Okay? And then you get both the answers wrong after that. Okay? And then IS, we know. They have told the IS is 10 amperes. Okay? Make sure you put with the things, okay? Make sure you put with the what units itself. It's better if you do that. Safe, no. Sometimes they'll give you the marks, sometimes they won't. So make sure you don't forget the units in the first place. When you're simplifying, forget the units, okay? If it's confusing to simplify like this, write it separately. Okay, make it a habit to write with the units in the first step, right? And then separate. If it's confusing for you to simplify like this, write it separately and do it. Okay, 10 cut, 10 cut. I can do like this. If you feel like you have to bring it to one side and do, that's also fine. Okay, 1. So IP is equals to 1 ampere. Okay, that's the answer. Okay, 1 ampere. Right. So that's it about the primary, secondary. Yeah, that's the question about that. Okay. Right. Now let's jump into that's it about electromagnetic induction. Oh, there's another question actually. Shall we do that? You all want to do that question number 5? Can you give me your opinions? If not, I won't be able to do hydrostatic pressure. I can give you an idea about hydrostatic pressure, but if you want me to do this question, it's easy, no? Question number, it's actually a past paper question, okay? Question number 20. I want to check how many of you all did the past paper. So that's why I put this question. Page number 23, not question. Page number 23, question number 5. They all want me to do this question. The question, the past paper. Can you tell me which past paper this is from? If you all know, let's see how many of you all did past papers. If you are doing next month, if you all haven't done past papers, I don't know what to say. So like, do you remember which year this is from? Let's see how many people are there who did the past papers and who know. Soon go run and check your past paper book, which question. Do you remember? You have to, if you all have done it so many times, so you will know which year and all. Uh, yes, Tejani, very good. So you have done past papers. No, was it's 2020. Okay. So since it's a past paper question, I feel like I don't want to do it. If you all have any doubts in that, I was planning to do it actually. I didn't think I'd run out of time like this. And I feel bad now because I told you I'll do hydrostatics also. I'll do hydrostatics now, right? So that I'll give it to you all, right? It's the 2020. If I can recall the question number, give me a second. Let me try to recall the question number. It's question number 9. Question number 9, B part. Okay. Sorry, question number 9. 2020, question number 9, B part. Okay. So this question, you can do it on your own. You have doubts, text me, send me a voicemail. If you can't tell the doubts, send me a voicemail, I'll listen and I'll reply to you, right? If you have doubts in the question, please ask me, okay? I was planning to do, but unfortunately, I have no time to do it. I'll send the answer to all of this, okay? I found it from different sources, support seminar, that paper, this paper, every paper. I'll send you the answer to all of this. Try it on your own. Ask me if you have any doubts, okay? So now let's go into hydrostatic pressure. So some of your this is how you all wanted me to do the session. That's why I'm following your advices. You all told me to teach theory, do questions, theory questions. For physics, 3 hours isn't enough to do that, right? So that's why I'm trying to somehow do everything together. Okay, I hope that's okay with you all. Alhamdulillah, at least we finished electromagnetism. Let's jump into hydrostatic pressure. Okay, hydrostatic pressure also, I'll make it short as possible. Sit back and watch. I mean, it's not a show to watch. Take a piece of paper and try to write it down and try to figure it out. If you even if you know the lesson, it's going to help you or not because I try to teach it in such a way that it's going to help you all. Okay, so the ones who are here now, if you talk about the hydrostatic pressure, this lesson is very easy. Okay, one of my favorite lessons other than electronics. So this one, this is composing of another 3 core concepts. Okay, I will not be able to teach everything, but I will teach in such a way that you all can understand. Okay. So this hydrostatic pressure is divided into 3 as the pressure of solid, liquid, and gas. Let's keep it interactive, okay? So now I will tell you all to go to the equation page. Okay, now if I just go on talking, you all will be sleeping now. So let's go to page number. Let's go to page number 16. Go to page number 16 and try to fill up till the pressure of solids only the first one. Okay, pressure here I have put the equations in one glance. Pressure of liquids. Can you write the equation or send me the equation if you have written? Let's see how many of you have done. Soon. I'll start with the equation itself. Yes. Wow, Bilal is so fast. Okay, P is equal to F over A. And pressure of lighter, what have I written? Pressure of liquid. Okay, pressure of liquid is rho GH. Okay, so what is F over A? Force over perpendicular area that is applied to, right? Sorry, perpendicular force. Wait, I don't know what I'm blabbering. Wait, give me some time. Okay. I'm like talking so fast. So pressure of a solid is F over A, no. F is the perpendicular force applied. So what that means is to a certain, let's say an object, you're applying a force from up. That has to be perpendicular. Okay. So perpendicular force applied on a certain area. Now this is an area. This is the pressure. Okay. The other one is, this is the pressure of solids. Okay. Pressure of solids is F over A. So write it there. Perpendicular force applied over area. The unit is N over meter squared, so it goes as Nm minus 1, minus 2. But the standard unit of pressure is Pascal. Okay. So same with the liquids. Liquids pressure is equals to H rho G. What did I say earlier? Rho G H. No, it's H rho G. Okay. I don't know who said that. It's not me. So pressure in a liquid is H rho G. Okay. This is the pressure in a liquid. This is the height, this is the density, and this is the gravitational acceleration. So if you're writing a note, so please make sure you write it: height, density of the liquid, and the gravitational acceleration. So you all know the concept, okay? So characteristics of liquid pressure here. You all know the characteristics from grade 7, I think, right? So pressure doesn't, what is it? It's like pressure acts in a liquid. If you take pressure acts in all the directions. We know that now from small days, we know that. Okay, pressure acts in all directions. That is one concept. Another concept is the pressure. Do you think now the shape of the object matters? Yes or no? Tell me yes or no. Yes or no. Now it's the pressure here, here, here. Same level, okay? Same level. Does it matter? Does the shape matter for pressure? Yes, Bilal, very good. No, Tejani, very good. Everyone's saying no in like so many O's. Okay, no. Muaz, very good. Ibrahim, very good. Oh, y'all are awake, no? Amna, very good. Okay. Right. So the shape of the container doesn't matter. For pressure, shape of the container doesn't matter. We have been learning this from small bits. Only the height will matter. Whatever the height. Now let's say this one's height is up, then yes, that is there's a difference in the pressure. Okay. So I'll tell you in detail what it is about, right? So the pressure at the same level is same. The pressure in liquid acts in all directions. Pressure of a liquid only depends on the height of the liquid column. It does not depend on the shape. So we know that. So those are the four things, the characteristics of liquid pressure. So all this is very easy for us. They can ask this in exam. Okay, they can ask this. I can't really guarantee if they will ask or not, but they will ask this, right? So go to question number 21. Sorry, page number 21. Page 21, question number 29. Tell me the answer for that. Very easy, okay? I don't even, if I give this to a grade 8 student, they might do that. This. Page 21, question number 29. Soon, if you'll have done it. I sleep at 3. Oh my God. Sleep at 3? When I don't sleep at 3. What? You study until then? What time do you wake then? I can only imagine. Probably 3 o'clock p.m. 3 p.m. Moaz correct. Yes. I just saw. Who is Agent Black? Okay. Right. Okay, so you have sent the answer, right? I think yeah, okay, so you have sent the answer. So it's simply very easy, right? So now they have just given 3 containers in different shapes, same as how I do. Okay. So it doesn't matter what shape it is or what size it is, it doesn't matter. Okay, shape doesn't matter. That's the whole point. Right? Shape doesn't matter. Okay. So it's the same point. No, that's all that matters. So pressure over here only they're asking this point. Okay. So they have told that it's filled to the same height. So that's the key word for us. We only need that. Now in the question also, if you can't really understand the question in MCQ, try to underline. Now when you're reading a question, if you're going out of that, now you're getting different thoughts. Now when you're in the exam also, you get different thoughts. Like, what should I do after O levels? What will I do after this paper? What will I do? So try to eliminate that. When you're reading a question, always write on it. Right. So now in this question, you can underline the keyword same height. Okay, same height. So that means same height means same pressure, no? So PA is equals to PB, which is equals to PC. Pressure is same, doesn't matter what shape it is. So answer is answer number 4. So all of you have told this, very good. Actually, even this is an, if you had noticed, this is also a past paper question. I put here and there past papers just to check if you have done or not. Okay, so let me dive deeper into this. Okay, so transmission, now I will have to, is it okay if I kind of wind up after teaching hydrostatic pressure? I actually had high hopes that I will do a lot of things with y'all, but unfortunately with the tube, we couldn't do a lot, no? What do we do? Do you think, is it okay if I send you an answer script? Will you all do it? Or what do you prefer? Do you prefer another session, which I don't know if I can do? Can you give me your opinion, please? Because y'all are here. Lucky 16 people. Shall I give you the answer script? Will you do it and ask me questions? Will you be able to do it? Answer script is okay. Tejan is saying it's okay. Others, Bilal says okay. I need your opinion. Soon, 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 soon. I can't see someone's chat. Okay. Allah knows best. Yes, Allah knows best. Okay. So I will teach you the hydrostatic pressure and we will do questions from hydrostatic pressure as I planned. So initially my plan was that only, electromagnetism, hydrostatic pressure. And then 10:30, what I'll be doing is I'll connect a circuit and show you all. And the magnets also will do something with that. And let's find out. Okay. Right. Anyways, it's not practical. No, in 3 hours, I don't think I can. I didn't think I can even do electromagnetism, but hopefully we completed some what was important, right? So questions. Now your responsibility is before tomorrow Tamil session to do the questions. Okay, don't just keep it and in vain. No, you're printed also if not. So do the questions. Ask me doubts. Okay, I will reply to you personally. Right. So now about this hydrostatic pressure, let's go into this thing. Okay, so now we're going to talk about the trans. Now this is the part that's hard for you. Transmission of a pressure in a liquid, right? So there is something called as the hydraulic press. Now this is the part that most of you find difficult. I can't say all of you, most of you. So here, what is the purpose of this is to lift very large, massive objects, like let's say car or something. It's there in these car service centers, all of these places, right? So to lift cars or something, to all of that, we need this hydraulic press. Okay, it is used to lift cars. So how do you do is you just simply place your leg here. It's like magic, right? You put your leg here, you put some pressure from your leg here, and the car will, rise up. That's the concept of this hydraulic press. Basically, transmission of pressure in liquid. So this is called as a hydraulic press or the hydraulic jack. Same concept is used when you're like putting brake in the car or like a hoist and all the same concept is followed. Okay. So here, what we do is, now I'm going to put pressure from here and it's going to increase. So how it's done is mathematically, you should think this. Okay, mathematically we think this. So let's say for an example, this is now the area of this surface or this surface area is 10 centimeters square. Okay. And the force that I'm applying here is 20 newtons. Okay. The area of this is going to be let's say what? Let's say 200 centimeters square. Okay. And the force that is coming up is going to be 400 Newton. So mathematically, it's correct. How I say mathematically is correct is, I'm going to find the pressure here. Now the equation you all told me, I'm going to use. Okay. P is equals to F over A. Force is 20 Newton. Area is 10. Now here, I'll just bring the square. No, it's not. Okay. So it's going to be 2 Pascal. Here also, I'm going to use the same thing. So I'm going to check the pressure from here, this side. P is equals to F over A. Force is 400, area is 200. Okay, then 2 pascals. See, now the pressure is same, right? Pressure is same. What I can justify from this is, throughout this whole liquid, the pressure is the same. That's all about this hydraulic jack. So how they can ask you questions is, they will not give you this force, okay? And they will ask you, can you find the force of this? How do you find that? You will find it like this, okay? Pressure of this side is equal to pressure of that side. Okay, I'll just put this as maybe X and this as Y. X is equal to Py. Okay, force over area, force over area. So put this force here, put this area here. To find the force, you have to put the area here. Understood? So that's how you find the force. That's how the questions can come. There is no other way they can give you the questions. Okay. So don't worry too much. You have to use this P is equal to F over A only. So how I say now the pressure is same throughout. You know, no. At the same height, the pressure is equal. Same height, only it's there. Pressure is equal. Okay. So that's about the hydraulic press. So this equation itself, you rotate, and use them. Okay, that's it. That's about the hydraulic press. That's all. Nothing else to think about. If you want to go in detail, again go to your textbook, open. There's so much in detail. It will enlighten you. If you haven't read the textbook before and you have only 1 month, it will actually give you a whole different sense of enlightenment. Okay, right. So now let's go to pressures due to gases. Okay. Now, solids, liquids done. Now, this is only liquid, okay? Now, you will ask, what is this? This is a liquid. Now, this is the liquid is only there here. There is no solid here, okay? The liquid will get pushed here, and the pressure will get transmitted. That's why it's a transmission of the pressures in a liquid, okay? Let us go into pressure of gases now. Now pressure of gases, okay? Let me check if you have questions to do from that. Oh, no, we already did, no? Questions. Tonight, I have the task for all. The task to do for all is, now I have told you all, no, this the theory now I'm teaching you all, right? So it's like a revision. You all don't have to study it again. You can just go through your textbook if you want. Get your 5 years of past papers, right? From 2024 backwards, right? 24, 23, 22, 21, 20, right? Get the papers. Go and check for hydrostatic. Now, you will do this only if you want to get an A, okay? If you all don't want to get an A, then don't do this, right? So hydrostatic and electromagnetism, right? So I have taught you all the chapter in a very brief way. So instead of going to your textbook, do the 5 years of paper for these two lessons only. Find the questions and do. If you have the classified book, if you have it, go. It's an advantage to do it. If you don't have it, then find the questions by yourself, put an effort, and do these questions on your own. Essay, MCQ, everything, right? Perfect these areas, right? And if you have doubts, ask, right? So do it for these two lessons only first, and then for the remaining chapters, I'll give you a plan on 30th, right? For now, this is the plan, okay? And answer the PDF. PDF. This is my tutor, because in like 3 days time I'll send the answers script for this. Make sure you do it, okay? Don't procrastinate, because procrastination is very bad, right? Because when I do it, I know it. So don't procrastinate. Before tomorrow's Tamil session, make sure. Now, one person said he's awake till 3 a.m., right? So I don't know what time you all are awake. So make sure before the Tamil session, you finish the tune. Wait for the answer script. I'll send you the answer script. Mark it. Ask me doubts. In the meantime, this is your other task, okay? Remaining physics question, biochemistry, along with the other tutors, I will discuss and come up with a proper solid plan on the 30th. Okay, so wait, come on the 30th, I'll give you the plan. We'll see what to do with that. Okay, for science. Right. Okay, so hydrostatic, now we have this one part, pressure due to gases. Okay. So pressure due to gases also, it's nothing hard. Okay. So let's say this is a YouTube, okay, not the YouTube that you're watching the live stream from. A YouTube is an instrument. Okay, like from 3 to 9:30. Okay. Anyways, so this is YouTube. Okay, or maybe you sleep, you wake, pray, and sleep like me. So that's also fine. Okay, as long as you do. Okay, so this is the YouTube, right? And we have the atmospheric pressure. Now this is a YouTube. Now YouTube, in the YouTube, you have liquid. Okay, this is a liquid column that you have. Okay, liquid column means water, whatever. Okay, so this is there in the chemistry lab. If you have a chemistry lab, when they show you what this is, you will know what this is, right? So in this YouTube, right, we have PATM here. PATM is what? Atmospheric pressure, right? PATM. Now, people who are new, they must wonder what is PATM, right? It is atmospheric pressure in a shorter term that we write. Okay, so pressure due to gases simply means there is an atmospheric pressure. Now, wherever you are on land, on bare earth, mountain, or wherever, there is always an atmospheric pressure. That's why when you are flying in the sense when you're going in a hot air balloon or whatever, or in the, what is that, in the, what you call, in amusement park, you have this merry-go-round, not merry-go-round, I forgot the term. ferry wheel, right? So in all of that, when you go up, you can feel the pressure on you, right? The air on you getting to you, right? So that is the atmospheric pressure. Okay. Now, so that's not my point, but that's not what I want to say. So here in this pressure due to gases, in questions, what they can generally ask you is this: find the pressure here, find the pressure here. Now, what is PA? What is PB? That's how they can ask. What is the value of PC? Okay, this is all they can ask in the paper, right? That's all, right? And this, if they say this is height h, what is PA? If they ask you, you should be able to tell PA is equals. Now there is a pressure from atmosphere, correct, but there is also a pressure from this height, right? So the pressure from this height is denoted by what? H rho g. This is like a, it should be like a revision to you, right? TATM is the pressure that's from up. Along with that, due to this height, there is another pressure. So it's going to be PA is equals to PATM plus H rho G. So previously we spoke about the characteristics of a pressure in liquid, right? So in the characteristics we said at the same level the pressure is equal. So that means PA has to be equal to PB, obviously, right? Because PA is equal to PB. So PB is equal to PA. Therefore, like in mathematics, in axioms or whatever, don't require axioms now. If PB is equal to PA, that means PB is also equals to PATM plus H rho G. Don't think too much. Now, don't wonder how and all of that. Just think about maths. Okay, if PB is equals to PA, that means PB has to be equals to PATM plus H rho G. Nothing complicated there. Okay, so we found what is PB, we found what is PA. Now our question is, what is PC? What do you all think is PC? Tell me. What do you all think is PC? Yes, somebody knows axiom. Ibrahim knows axiom. Yes. What is PC? Yeah, Miss, these days no sleep for us. I am nice to sleep in. Sorry, okay. I didn't want to hurt you all like that, but you all can sleep after O level, so. No, no, it's not. Why do you think? No, no, it's not PATM minus HOG. It's not, right? If you're saying like this, right? If I rearrange this equation, right? The pressure here, now think logically, I'm not even looking at my book, so I don't know, right? But I'm thinking logically. I'm telling you this pressure here. Now, if you're the person here, you can feel the pressure of the atmosphere, and you can also feel the pressure of the HOG. Both the pressure is acting on you. That's why PA is equal to PATM plus HOG. The problem with y'all is y'all are memorizing the equation. That's why you're saying it's minus. How did the minus come in your book? It would be like this, right? PA, now if I did HOG this side, is H minus HOG is equal to PATM. Okay, so that's how it is. Okay, do you understand? That's the answer for PA. Yes, everybody's saying, okay. Tejani, everyone told the answer. So PC is PATM. So let me know if you still have the doubt about this minus and plus, okay? I will clarify to you personally, right? I hope everyone understood, right? Just think about it. Think that you're the person here, but you will not only feel this pressure of this HOG, right? You will also feel the pressure of this PATM. The same pressure is transmitted here also. So that's the pressure there, okay? So don't get confused. So right, so that's about that. This is the pressure. Why PC is equals to PATM is on top of. Think about PC here. What is there on top of it? Only air, right? You can't see the liquid there now. So the only pressure that's acting there is PATM, the atmospheric pressure. Only pressure that's acting there is the atmospheric pressure. Okay, so that's it about that. So the instruments that are used to measure this atmospheric pressure would be the mercury barometer, aneroid barometer, all of that you have in the book, right? So the person called Torricelli, he is the one who invented the mercury barometer. And why I am talking about atmospheric pressure so much, this application is used when you're drinking in a straw. When you're drinking in a straw, also same thing happens. Now, if you understand, now when you're drinking in a straw, you try to suck the this thing in, right? The water or whatever. So there's going to be a high pressure inside. And the pressure is going to go, okay, from a high pressure, sorry, here is going to be a high pressure. Okay, the pressure, because why is it high pressure here? There is atmospheric pressure. Okay, so much of pressure, right? So when you're sucking it from the straw, there's going to be so much of pressure on this side, just like how you're pressured now because of O level, right? So there's so much of pressure on this side, so pressure is high. So when you're sucking it from the straw, here there is not much water. Okay, so the pressure is kind of low. Always in science, you have learned this. Whatever moves from high pressure to low pressure. Why there is a low pressure? Yes, because we are sucking water. No, there is not much water here, right? So there is no pressure for water here. But here there is so much pressure. They're like all the water molecules are like bumping onto each other. They're like, oh, I have to go first. I have to go to the straw first, right? So pressure always goes from high pressure to low pressure. That's what is happening here. That's how the water goes to the straw. Same concept with the siphon method. Siphon method, same thing. So I can't really explain that. It's also another concept. Same thing, right? Same with the rubber sucker also, right? I was waiting to explain all of this, but 3 hours is not enough apparently, right? So if you have any doubts regarding that part, let me know, right? Now let us go into the Archimedes principle, right? So Archimedes principle is also very, very fun, okay? So it's a story for another day. If you are doing 2000, if you are December 2026 O-level students, don't worry, I will tell you all this. But unfortunately, if you are February students, you can text me personally. I'll tell you the story of Archimedes. Okay. But for now, I will just tell you the theory, the principle of Archimedes, right? So Archimedes principle, if I want, I can read it to you, but I will not read the principle to you. So Archimedes principle, you have to know this by heart. Okay. Archimedes principle. It's a person called Archimedes who came forward and he said, I know this principle, and he came forward and told this principle. Okay. He says something like this, right? So now you have, let's say you have a bucket of water and you have something floating on it, let's say a wood or something. He says that when an object is floating like this, or whether it's fully submerged or partially submerged. So what do you mean by fully submerged? So the word, physics, you have this some words like submerged. Submerged means it's just put immersed, okay, inside. Okay. That's why sometimes I feel like, what is this word? What is that word? It's not hard, right? Sometimes this is partially submerged, this is fully submerged. Okay. So when an object is partially or fully submerged, okay, there is an upthrust that is acting on it. It seems upthrust is an upward force. You can feel it right now. If you have like a what do you say? If you have like a a bucket of water or something, if you try to put I have tried this. The soap case or something inside that, it will float. But I try to put it inside, I can feel a force coming upwards. That is the upthrust, the feeling you get when you try to immerse something in water, it tries to come up. That is the upthrust. Okay. So always the stuff that are partially or fully submerged in water, there is always an upthrust. And the upthrust is equal to the weight that is acting on it. Weight is mg, so I'll say it as mg. It is the upthrust. So that's all about what Archimedes is saying, but he's saying another factor also. Now let's say initially in your bucket of water, let's say this much was there, okay, and randomly you put an object. There's a story behind it. It's a nice story, but unfortunately I have no time to tell that one. Okay, so before you put this object in the bucket of water, it's full enough. Once you put it in the object in the water, water is going to splash out. There's going to be an amount of water that is collected. Okay, you have this experience, right? In small days also, you try to put stuff in your bathtub, water splashes out. So that's what happened to Archimedes also, right? So this volume of water that is displaced, or the volume of water that comes out of the bucket, is equal to this volume of the object. That's the whole point. That's what Archimedes principle says. That's it. The object weight is equal to the volume of water that is splashed out or displaced. Okay, so that all you have to say in a very fancy way, as object is partially or completely submerged or immersed in a fluid, it experiences an upthrust. That is one thing. The upthrust is equal to the weight. That is the second factor that you have to say. Okay, is equal to the weight of what? Weight of the fluid that is displaced by it. This is the third thing that you have to mention in the Archimedes principle. So you can break it down. Now, when there's a principle or a law or something, always break it down into short crumbs so that you can, when you're eating also, you won't put the whole bun in your mouth. No, you will bite it into small pieces, right? Same with definitions, even in bio, same thing. Definitions and all, break it down into short, into small, small crumbs that you can swallow, right? And swallow in a sense, not like, not in a literal sense, like, in a theoretical sense, okay? So that's what Archimedes principle is. So go to page number 17 now in the tute. I'm not able to share the tute. So you'll have to be able to check the PDF. Page number 17. Yeah. So here I have given space for the Archimedes principle, either after the class or now. You can soon write it if you're writing it. So write the Archimedes principle, write the Ohm's law, complete the tude, okay? It's not in vain. No, if you have printed, just keeping the tude and sleeping, right? Okay, so that's about that. So there's another equation as well, right? Actually, there's nothing much. That's it about the Archimedes principle. Yeah, simple, right? So upthrust is equal to the weight of the water displaced. Either write this somewhere if you don't know. Okay, that's exactly what the Archimedes principle says. Okay, right. So with that only questions come, right? So the apparent this is another equation that is commonly used. Just remember this, right? The apparent weight is equals to the true weight minus the upthrust. From this, you can find the apparent weight. What is apparent weight? The fake weight, the weight that is now the true weight of the object is the one that is in air. Now we'll say you have the block of wood, that true weight. Now if you're 40 kilo, I don't know how many kilos you are. If you're 40 kilo, your true weight is going to be 400 newtons. Okay. Once you get into the water, your weight is actually going to be minus your upthrust. Okay. Your weight is going to be less. So if you all are really fat, get into water. Okay, I'm just kidding. Okay, don't do. Okay, I'm just kidding. It's a joke. Okay. So this is this is how you find. This is another equation that you all should know. Okay, so that's it in the Archimedes this thing. Okay, so if I were to give, that's the whole summary about the Archimedes principle. So nothing much really. Okay, so when you're floating, so there's another small kind of a short note that I can give you if I'm giving. The short note would be this. You can copy this down, right? Let's say an object is just normally floating. Okay, floating. This is submerged and floating. Okay, this is sinking. Okay, not the sink that you have at home. The sinking. Okay, this is submerged and floating. I'll just press S and F. Submerged and floating. This is sinking. Okay, and this is floating. If you can take this down, it will be nice. Okay. Here, what is happening is here it's partially submerged. No, this is what you call as partially submerged. If it is partially submerged, the upthrust is actually greater than the weight. That's why it is not fully floating, right? The weight is not high. If you're like a very heavy person, you will be sinking, right? So the upthrust is higher than the weight. That's why your floating is high than the weight. Weight is small. Weight is kind of small. I put it like this, okay? So if you're like, let's say, submerged and floating, your upthrust is equal to the weight. That means it's equal. I'll draw the arrow also equal length. You can copy this. It's like a cheat sheet, okay? Don't go and take this to exam and say I gave you a cheat sheet. It's just I didn't understand about apparent weight theory. Wait, I'll explain that again, Tejani. I will do it. Right? And sinking is the weight is higher, that's why it's sinking, and the upthrust is lower. Okay, I do a small arrow. That's why it's sinking. Okay. So this is a cheat sheet that you can use, right? So this is the whole concept in just a diagram. Okay. Right, so that's it about hydrostatic pressure. So someone didn't understand apparent weight T. Okay, I will teach you that. Miss, can you tell the story by 2x speed? I already talked by 2x speed. No, so if I tell it to you, it will be 4x speed. When an object is partial, okay, someone has sent the answer. Okay, nice. Do you have classified questions? I have questions, but how do I send it to you? Like, but which chapter do you want? You tell me I can send. I can't send the whole book now. Yeah, I will send the answer script for the entire thing, right? Then you can figure it out and do it. But actually, I should have enough determination to do it, okay? If you all don't have, because if I do it, I can guarantee I'll get an A. But you should sit and properly do the tude, answer script, check, mark. That's what you should do, right? The questions are actually pretty important. That's why I put it now. Right. So, yeah. So whoever wants the classified, send it in the study group or send it to me personally. I'll try to check pictures and send. It's actually from another teacher, okay? So I will send with her watermark itself. If not, it will be like I'm stealing her. Right. Yeah, so that's pretty much about the hydrostatic pressure. There was something else that I have to clarify about. Okay, so yeah, so that's it about it. So if you have any questions, please ask me personally. Go to page number Go to page number 21. Let's do one last question because I didn't do much question with you all. You don't feel angry with me also. Someone asked me a question, no? What is apparent weight? Okay, okay, okay. Wait. Apparent weight is something like a fake weight. Okay, so until then, others go to page number 21. Oh no, I can't see my screen. Give me a minute. Go to page number 21 and do question number 30. I'll soon this thing and come. Can you all do? Can you do it until that? I'll be back soon. Okay. Once again, I'm repeating question number 30, page number 21. It's a very pretty easy question. If you have done it, send me the answer. I'm watching your chats. Okay. By the way, this is the last question that we are doing. After this, I'll be doing the circuit thing and the magnet thing, and then we can wind off. Okay. So before 11, I can guarantee we'll finish it. Also, if your friends are sleeping, call them. At least now let them join and watch the circuit thing. If not, in vain. No. Hold on. Check. Is the admin here? Please reply to me. Can you please allow me to switch my video on? Where is this admin? Maybe she also went to sleep. Uh, I can't switch my video on. No. Okay, I can sort it. Okay. Can you spotlight my screen as well? Okay, right. So I know my this thing is a bit slim now because I changed phones, right? Oh wait, give me a second. Right. So have you all sent the answers to me? We're almost done. Okay. Sorry for taking your time. Okay. Right. So you have sent me the answers. Right. So in this question, right, the answer is answer number two. Right. So basically, what they're saying is the weight. Now it's directly the Archimedes principle. For questions like this, is the direct answer. Right. Question. The answer is answer number two. Why? They're saying the weight of the liquid displaced by A is equal to the weight of the part of A immersed in liquid. That means now this is like this. No, the block of A is there. So they are basically saying this part of the block is only displaced with states. So that's the answer. You don't even have to read the other options. Others are just they've just given you lies. Okay, so it's others are all wrong, right? The volume of liquid displaced by A is equal to the total volume of A, density of A. That's all wrong, right? And anyways, I think I had personal doubts, right? So ask me personally. So like now I'll do the circuit thing and show y'all, and we have to wind up because if not, automatically Zoom will end at 11, right? So I will not do anything else. You have sent me some doubts personally, right? Send it to me to my number. My number is, I already told you all earlier, 072 663 5522, right? It's like his heart number. So anyways, so send me the number. See, send me the question to this number. I will personally reply to you, whatever questions you all had, okay? If I wasn't able to reply. So I will do the circuit thing now and we can end the session, right? So give me a second. If your friends are sleeping, soon call them, ask them to come from. It's nothing big, okay? So I just got this circuit because I thought it was cute. Okay, I don't know if it's bright enough. So I have to fix it. I fixed it earlier. It's not fixed. I don't know if I can give a close-up view. Let me just check. Well, y'all can get this circuit. It's there in the bookshop and stuff. It's nice. It's like I have to tighten it. So this is a simple circuit, right? You have a bulb, you have a switch, battery, and the wire, of course. And wait, I have forgotten. Oh, there are these clips and stuff, right? So I can tighten it. I already set it up earlier, so I know it will take some time. Let's see if it works. Can you see? Oh, the light is very low. I don't know if I can bring it close. I'll bring my camera close and you can see, Be careful, wear rubber gloves. Very circuit tani. I was telling my friend that this can light up my whole room because it's that small, sorry, that big, no. I don't have gloves and all for this, but we can manage it for now. I guess. Oh me. Sorry. Sarcasm on point. Yeah, I'm good at. I have my language is sarcasm. So yeah. Okay. I think it's fine. Ignore my dirty hands, but it's all because of the board and stuff. Just a second. I think I can see, right? Can you see? Oh, I think I have titled from this side. Okay, can you see? Can you see? Small blow. You can see? Oh my god. Wait. There should be a small blow. Ah, here. Can you see? Is it there? I can see. Can you see? Ah, I saw. Okay. Actually, it's supposed to glow very nicely, but unfortunately, this is all they gave me from the shop. They scammed me. Yeah, so that's the bulb. I think I should press harder. See? Oops, I'm not showing camera. Oh no, 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 no. Can you see it? Can you reply? I don't know if you can see it. See? You see the light, right? A small, it's like a dot. Okay, so that's about this circuit. The other thing that I want to show was the this thing. the magnets. Last time also I showed the magnets thing. Okay, let's keep the circuit aside. So I got these papers. Now the paper is dirty. So I usually keep the paper like this. Okay. And I put there's these iron filings. Okay. So there's this thing that I got it with that. Okay. This is called as the iron filing, or you can call it the iron powder. And I will spread it on this. Oh no, not on this. Sorry. I'm also getting confused. You have to keep the magnet, okay? First, I have different kinds of magnets. Let me flex my magnets collection. So these are the magnets that I have provided to you. Okay, there's a fancy thing also, a trolley like a thing also. So by the way, I'm going to use this, okay? I'm going to use this magnet for now. I mean, that's the only thing I can use. And then I'm going to cover it with this. Okay, if not, it's going to be messy. Cover the magnet with this. And I'm going to, like, I feel like I'm a YouTuber at the moment. I'm going to put this thing, okay? So give me a minute. I'll be back. So I have to like spread it so you can see this thing, the field lines. What metal is that magnet? I have no idea, but you can spread now. See, okay? When you spread it, you can see the field lines properly. Yeah, this is the field lines. So in the book course, they would have shown you this, right? I'm showing it practically. These are the field lines. I'm not purposely doing that. Like if I just spread it like this, I can see the field lines. So this is the North Pole, South Pole, and it's getting concentrated. Can you see that? Okay. I'll ask the admin to take nice photos later. Admin, are you there? Can you please take nice photos? Okay, yeah, so this is how it is, the thing. I can also try it with this, but since I have no time, I'll just not, because this also it will nicely show we did it last time, I think. It will show the iron filings for this also. These are the field lines, okay? So you would have seen this in your textbook. And about the compass, oh, there's another thing that I want to say. So you have a magnet here, no? Where is the compass? Oh no, my compass is gone. Oh yeah, it's here, okay. So when you keep a compass here, you know in your book there's an experiment which says that when you move the compass around the magnet, the reflections are changing. Can you see that? When you move it, it's going a full circle, right? This is another thing that I wanted to show. So you can get these, small things. If you're planning to do A-level science, now if you know O-level science is done by next month, for the ones who are sitting next month, the others can, buy this and try it. It's nice, it's fun, right? Anyway, so that's it, I guess. I hope you all learned something from today's session. And thanks for staying. Now, I think around 13 of you are here, right, till the very end. So all I can say is thank you. Please subscribe to my YouTube channel and goodbye. Just kidding. Okay, I feel like YouTube at this point. So if you have any questions, please ask me on WhatsApp. I'm sorry that I couldn't really answer the truthfully. That wasn't the initial plan anyway, to teach you all hydrostatic pressure and electromagnetism only. I'm sorry for keeping you all until 11, but I hope you all took something from today's session, right? If you all have any questions, please ask me. Any help until the exam, I'll be there, okay? Okay, Barakallah Feek. Walaikum Salam. Good outro. That's all. You're welcome. I'm so Gen Z. Yes, I'm a Gen Z. Okay, thank you. Bye bye. Okay, Barakallah Feek. 2% in your device. Good night. Okay. Barakallah Feek. Bye bye.